Okay, so we should be live. Let me just check here. Go to my page and check on my account. And I don't think there's anyone in the chat. One second. Beautiful, and we are live. So I'm here with Fight the Deception. So Fight the Deception, how about you go and introduce yourself and just tell us a little bit about yourself.
Yeah, I have a YouTube channel called Fight the Deception. My name's Matt. I'm from Taos, New Mexico, outside of Taos. I'm a flat earther. Been a flat earther for about 3 years. Been looking into the flat earth for about 4. Pretty much full time, I'll say. Anywhere between 7 and 16 hours daily. That's reading books, making observations, going through rocket launches, NASA footage, different documentaries, debating. I'm also a moderator of the largest flat Earth group in the world, 124,000 members last time I checked. They've been kind of keeping the number at 125,000, even though we have people that join every day. The number's not going over 125,000 for some reason.
Is that Nathan Thompson?
Yeah.
That you're? Yep.
Yes.
Yeah. Cool, man.
And basically, debating with globe believers I've been a moderator for like a year and a half. Prior to that, I exhaustively went through all the proofs or the evidence, if you want to call it that, the globe model presents, or the claims that they make.
Yep.
I've went back in history to the to the books, to the did research on the actual people that a lot of these theories that were presented that helped shape our world. I wanted to know more about those particular people, as well as the influences of those people.
Like Aristophanes and stuff like that. Is that what you?
Right.
Yeah.
And I tried to go back about, at least 3 or 4 generations back, in 3 or 4 people, that how it got down the line, how things were passed along, different beliefs at different times. Like I said, I've exhaustively been through all the globe proofs / evidence that, and not only that, but being a moderator and having people, constantly asking questions and stuff. If I didn't know something, I wanted to know more. I wanted to, I wanted to be able to have the answers. Because I wanted to know myself. I came up with a lot of the question. The evidence is on my own, but there was some that were presented that excuse me, that I hadn't heard of before.
Yep.
And so I wanted to see what the other argument was, because here's the problem with me personally. Growing up in school, it was always presented. The globe was always presented as a fact, as a given. Basically, it was you know, um, something that was proven, by numerous amounts of evidence.
Yep.
Now, I remember when I was in school, the top, let's say the top 3 or 4 proofs that that they always told you that proved, okay, and I say proved because that's the words they use, proved that the Earth was a sphere, okay, and I also was taught that Columbus, the people, and I've read books, I've read several books that was talking about Columbus. It was from the 1800s, books from the 1800s that were talking about Columbus, and it even says that they found his journals, and it talks about his journals, and that Columbus had a hard time getting funding to to uh, to make the trip because most of the people in the world thought the Earth was flat,
Yeah.
and a lot of the kings and a lot of the people that Columbus had went to try to get funds, they turned them down because they thought they were just going to lose their ships because they thought the water just kind of pours
Yeah.
off somewhere.
They
Okay,
fall off the edge. Yeah.
and okay, but Columbus, talked to Queen Isabella and was able to talk her into it. She had a council of all the smartest, the professors and all the philosophers and all the people. And this is out of one of the books I read, and it basically says that they're like, kind of like everyone was kind of like, you're a fool because you know everyone knows that the earth is flat, and
So
that's not verbatim, but
yeah.
and then more recent times, like the last couple of years, I've been hearing from people, and actually it's from a book I think that was written.
Can I just
It was written.
before
It
we
was
get too
written in the night.
sorry.
Okay, okay.
Sorry, man.
I could
Before,
go. I could go on. I mean, it's like
oh
I
yeah,
could go
yeah.
on. There's so much stuff. It's like,
Before we get too
but
far away from it, I can see a really stark parallel there. Is that when you were at school, you were constantly told, the Earth's a globe, the Earth's a globe, the Earth's a globe.
right.
Yeah, I can see how you have some a problem with that.
Well,
And now, but
it's
when I
no, no, no. The
what
problem. Let me tell you. Let me tell you what the actual problem is. Okay, the problem is there's legitimate arguments for these
oh yeah,
several
100%. No, no,
for these
this isn't
several
even that
proofs.
far into it. This is just a quick
Okay.
just when you said that Columbus was going everywhere and everyone kept saying, "Come on, man, the Earth's flat." Everyone knows Earth's
Yeah, I
flat.
mean
It's pretty much.
that's just one that
Oh no, I just
mostly it's circumnavigation
yep,
and ships disappearing over the horizon,
yep,
and the third one would be lunar eclipses. Okay,
yep.
those are the three that I was always taught was a solid, basically proof, that the Earth is a globe. Now, now you can go. I just wanted to clarify that a little bit better because
No, no, no,
the Columbus the Columbus thing is related, but not as much as
yeah,
these other three things.
definitely. My point was more because it wasn't so long ago that everyone felt the same way about the Earth being flat. And there was people saying, well, I've done this observation. This is what I see. The Earth's a globe, and eventually, the Earth's a sphere. Sorry, sphere. And eventually, that was kind of became mainstream. So I'm asking you, is that what you are hoping to see happen again, but back into the realm of a flat Earth? Is that the kind of the end goal for the whole movement, or
Honestly, I just want the truth to be out there.
right,
Okay,
right? So
because you can agree, I'm sure, that if the earth is flat and everything else moves around the earth, that puts us in a special,
that would be
that changes
amazing.
it
That would
change
be
it
like
changes everything,
yeah,
right?
everything that we know, it would be amazing, and that's why it's so interesting. And I think
Yeah.
um, uh, uh, the problem is that a lot of people handle it so poorly. You know, and one thing I do hear a lot is what you just said. Pretty much everyone that believes in the flat Earth says exactly the same thing. They all say,
Yeah.
"I just want the truth," which is fine.
Yeah,
Everyone wants the truth.
and I mean,
but what I want to really point out is that a lot of the time, and not all the time, otherwise there wouldn't be an argument, but a lot of the time, you can sit down and someone will make an assertion, and you can go through it step by step, and that's why I like to have these sort of discussions. And you can get to the bottom of the truth. And sometimes the truth isn't what you thought it was walking in. Now, you need to be intellectually honest enough and mature enough to, at the end of that, say, you know what, I was wrong. My assertion was wrong, and then you just move on from there. But what I find over and over and over again is that people do not do that. So what you said, I like, and I'm not trying to insult anybody here, but that just happens so often. And I'm sure you've watched just as many flat Earth debate videos as I have, and you can see the same. So
yeah, I'm sure.
But everyone wants the truth. That's it. No one's out there looking for a lie unless they're trying to take advantage of people. So those type of people,
Yeah,
stay away from those people.
I think that there's people on both sides of the. I know that there's people on both sides of the argument, of this particular argument, that are more in it, for, or a lot of them are in it for money anyway.
Yeah, money and fame, or whatever you want to call it.
And me personally, I don't ask for money. I don't have a Patreon. I don't I don't ask for any kind of support from anybody,
No.
or or try to sell sell shirts, or excuse me, or
Yeah.
but I've seen a lot of the globe side, more than the flat Earth side, I'll say, that are they're having debates every day. They're doing, they got super chats going, and they're making all kinds of money.
Yeah.
And so for those guys, to me, for the debate to ever be settled, the, it's not going to happen, because the money, that's where the money's at, right? For them right now. And some of the flat Earth channels do get money too. Nathan Oakley, I think, gets pretty good.
Yeah.
But primarily, I don't see as much. I don't see it as much on the flat Earth side. I'm not saying it doesn't happen, but
Oh yeah, I mean, look,
so
we can both agree on that. And monetizing it doesn't make it true. So
right.
I think it's just a
And
personal point of contention, really, for me.
yeah.
Hmm.
Yeah. So
So,
I don't. A lot of people, I think that even talking to people that make money on it is kind of it's kind of pointless, because
yeah,
because if they're just doing it for money, then they're never going to concede to any points that you make. They're never going to say, huh, like, for me personally, I came into this as a globe earther,
yep.
and thinking that I had, and I heard about these flat earth people, and I'm like, what in the hell? And I came with the popular science 10 proof type of thing,
Mm-hmm.
and every single one of them is horrendous. I mean, uh, that was actually popular science 10 ways to prove the earth is not flat, was actually a real wake up call for me, because I looked at that and I was like, this is the best proofs that they're listing as for the globe, and I'm like, holy cow. It's like their little drawings and their diagrams were just totally deceptive. you know uh there's just and then okay, here's another thing. There's like all these mainstream TV shows that are excuse me. There's all these mainstream TV shows like I'll say PBS.
I don't know what any of those are. Here in Australia, we don't get any of that, but that's
There was a. Do you know who Stephen Hawking is? You ever heard of
yes.
Stephen
Yep.
Hawking?
Yep.
Okay. Well, so you would consider him. What would you consider him? If I was to say Stephen Hawking, what words would you associate with that?
With Stephen, what word immediately black hole comes to mind.
What? Say it
black
again.
black hole. Black hole comes to mind.
Black hole. Black
Yep.
hole. Okay. Yeah. Okay. So, but he's a
He's a physicist. Yep.
astrophysicist,
Astrophysicist.
right?
Yep.
Okay. Or he was. Okay. So he's a pretty popular guy. He's wrote several books, and
He has actually
um,
just finished reading A Brief History of Time not too long ago. It's a great book.
A Brief History of Time.
Yes, it's a It's
I
just
think there's another one. Wasn't there another one too called? Or maybe that was a movie. I'm thinking of a movie.
the movie about him. That was a good movie as well.
Yeah, there's a movie about him. I thought it was called The Theory of Everything, or
Yeah, that's probably it.
I think that something like that. Anyway, so there's a conspiracy about him, but I'm not going to get into that.
Yeah.
I'm just gonna
Yep.
I'm just gonna act as though Stephen Hawking that was the real Stephen Hawking, and
Yep.
he really did. Okay, so he had a TV show here in the United States. It was on PBS, which is Public Broadcasting System, I think.
Yep.
And Discovery Channel. I don't know if you've seen that. But,
Yep. Yeah, we have that.
okay, so Discovery Channel / PBS, and it was Stephen Hawking was the host of the show.
Is this the helicopter experiment that I keep hearing about?
Yeah. Well,
Yeah.
that was one of they did several, if you want to call them experiments or observations or
Yep.
but um like they had several things that they did. Okay, one thing was they shot a laser. They had a lady on the shoreline,
Yep.
and before you even get to that, they introduced the people. Okay, and he says, I've selected 3 average people to conduct some experiments and measure measure the Earth. Okay, so so he introduces the 3 people, and the one guy's, whatever, and they get to this other girl, and she says, oh, or during the show sometime, they give her kind of like a little bio, and she says, oh, my name's Kat, and I'm not a scientist, but it's really cool to be able to participate in this type of. That was kind of where she was going with it.
Yep.
I'm not a scientist, but this is really cool that I'm getting to do this. So they do these experiments, and one of them was they had a laser supposedly leveled. They didn't show they didn't show them level it or anything like that. And you see the laser kind of looks, because you can see the water, and then there's a laser there, and it's not even it's not parallel with the water. Okay,
Right.
but but they hadn't done anything at that point. They sent these people out on a boat. Okay, this not a big boat, but bigger than the ones that the um, National Geographic used at the Salton Sea.
I have seen that
But
one. Yep.
so they took like a little rowboat out there or something.
Mm.
This one was a motorboat. It had a little cabin and all that covered. It was probably, I would say, about 6 to 8 feet off the deck of the boat,
Yep.
extended. Okay. And they go out, I think 500 feet first, and they shoot the laser, and then they make a little mark on this whiteboard that they have set up on the side of the boat. Okay.
Yes.
They make a little mark, and then they go out. I think it was 1 mile, something like that. And then they shoot the laser again to make another mark, and then they go 3 miles. Okay, now
Yep.
3 miles, they shoot the laser, and now this guy has to climb up on top of the railing of the boat, reach up, tippy toe type thing, and make a mark um, way up high. Okay,
Right.
then the scene cuts to another scene, and it says, okay, we're going to be heading back. Well, the laser, at the same time, the laser actually hits the lady that was standing on the deck of the boat. It hits her on the hip. Okay,
Yeah. Yeah,
the
sure. I
laser
mean,
does.
I see what you're saying. And
Okay, so that's one discrepancy. Okay, that's
yeah,
just one
but
discrepancy.
you do have to understand that when they do cut together TV, they don't film them in chronological. They don't film them in order. So they might film the end of the show at the start of the scene. Do you understand? It's not always filmed
Well,
in order. So it's really
yeah,
you could be
okay,
right, but it's far too
okay.
it's
I
far
could
too.
I can I can accept that. I could accept that, even though it shows them in the boat and saying we're coming back.
Yeah, 100%. But
Um,
they could have filmed that 6 weeks before the scene that you saw it.
sure,
It's
yeah,
far
sure,
too.
okay. I'll accept that. Now, there was another experiment where they took a helicopter, okay, and they set up a telescope on one side of one shore,
Hmm.
okay, and they took two of the people got in a helicopter and flew over to the other side, and then they descend down. They
And
start to they start
it disappears. Is it?
it disappears
Right.
behind supposed curvature. Okay,
Okay.
and then the guy, he says, okay, raise up so I can see where you're at, and
Yep.
I'll tell you when I see you, and you tell me how high you are. So they start raising up, and then he's like, oh, okay, I could see you, and they're like, he's like, they're like 24 feet. The helicopter pilot says
Yep.
24 feet, and at 6 miles, that's matches the globe prediction perfectly, right?
So what? When you say globe, I'm assuming that you've put this into a calculator and got it out. What was the? Do you know the map
Yeah,
that's used there or not?
yeah.
So did
Well,
they take observer height and
they
take refraction and everything into account, or did they do it live?
they used the 8 inches per mile squared. Okay, on the show.
Over
Um,
6 miles, was it?
at 6 miles, there would be 24 feet if the observer height was zero.
Yeah.
Okay, because you have to factor in the observer height, right?
Yep. Exactly.
So the telescope height above the water was like, I think, 3.5 feet,
Yeah.
a little bit over 3 feet. So, but it's like they didn't factor that in. Okay,
Yeah.
they didn't factor that in. So that was another little kind of discrepancy there. But the main point of that part was they showed the helicopter descending. Okay, and
So
there's these three. Hold on. There's these three birds that fly by on screen closer to the camera than the helicopter is.
yep.
Okay. Then there's another scene, okay, where it shows the helicopter, or no, it shows just the birds fly by. Just the birds flew by, no helicopter there. Then there was another scene that has the helicopter going down, and the same three birds fly by, and you can overlay it. You can
Yep.
overlay it over the other one, and it's the same exact. It's so basically they added in the
Yeah.
helicopter.
So that's what you're saying. It's the helicopter's photoshopped in. Is that what you're saying?
Um, yeah,
Uh, Edited in CGI.
basically.
Edited in. Yeah.
Hmm.
Well, look. I mean,
And
honestly,
and then okay, here's the final, you know, nail in the coffin for me is the lady who in the show, she says, I'm not a scientist, right?
yeah.
Well, come to find out, she has a YouTube channel. it's called Doing Science with Cat or something like that. She has a doctorate in biology, and it's like,
We all know
I mean,
biology is not a real science.
yeah. And then so she even says on her show, like, I'm a scientist on this on her
Yeah.
on her YouTube show. She says, she's on there quoted as saying, "I'm a scientist," and then on this other show, she's like, "I'm not a scientist."
Oh,
It's
look,
like, and that I mean, and not only that, but that's just one example that I can give you a lot of different
yeah. Look,
specifics that are wrong with it. Okay,
I think we
but
can both agree that showbiz is it's just
yeah,
not
all the
trustworthy. So
ones,
that's
all the mainstream TV, the National Geographic, all those guys are just liars.
yeah. So
I
you
mean,
just tools to perpetuate the line, and that would be that's your assertion.
well, okay. For example, at the National Geographic one, when they show it on TV, they show half of what they did. Okay, there was
Yep.
other things that they did that
What
they didn't put on the show.
wasn't there a
For
flat earther
example,
there? Wasn't there a flat Earth believer there for that one, or am I mistaken?
there was a bunch.
Yeah.
And see, what they did is one of the experiments that they were supposed to show, what that they did when they were there, was they filled up these balloons, these weather balloon, not weather balloons, but like big white balloons, and they were supposed to let them go up in the air, and whenever the people on the other side, however far they were, could see them, then they would notify them and all that.
Right.
Well, the thing is those people. There's a guy who was there, who was actually holding the balloons. Okay, and
Mm-hmm.
he was talking to his friend across the lake, trying to um, locate the position because they didn't really know exactly where they should be looking for these people.
Yeah.
First of all, it was totally bad conditions for that type of observation. It was like 104 degrees, and you know, there's all kinds of problems with it. They don't even know where the people that they're looking for are going to be at. Well, so there was somebody with a P900 that actually found them
Mm-hmm.
before they found them when the balloons were still on the ground. So they didn't have
Was
to let the balloons up in the air, which they still let them up in the air.
was this part filmed?
But
Was this part where
yeah,
they?
oh yeah, it
Yeah.
was it was filmed there. But when the show came out, they chose not to show that.
No, that's what I'm asking. Did any of the bunch of flat earthers film that part? Because that would be a pretty
Yeah,
exciting thing to
yeah.
film. So
They're
where can I
they're
go
they're
for that?
well,
Or do you just want to send me a link
the
later? That's fine as well.
the video that I'm talking about
Yep.
is the guy. It's the guy that's on on the guy that's holding the balloons. Okay,
Mm-hmm.
and he's talking to his friend, and he now I guess um I
Yeah, but
guess you could
what I'm asking is,
I guess you could say that he wasn't on the phone with anyone, even though he was on speakerphone. But personally, I haven't seen the footage
well, that's
from
okay. No,
across the
no,
lake.
yeah, that's okay. I thought that you had. I thought that you were saying that there is footage saying that.
Well, the footage that I have is the guy that's holding the balloons
Mhm.
talking to his friend, and there's even a guy from National Geographic standing there
Oh,
with
okay. No,
him.
I actually know what you're talking about now. I do know what you're talking
Uh,
about. Yep, my bad.
you see
Yeah,
that?
I have seen now that yeah, they eventually get there in the end. Isn't that right?
Right.
And he spots him
And
with the cat. Okay. Yep. No, that's
there's
good.
there's there's just a lot of things that they leave out, or they edit them.
Oh, definitely. And look, like I said, you and I are going to agree that anything in mainstream media has the possibility, the capability to be manipulated. And I'm not going
I
to argue
just don't.
about that. So I don't.
I
But
okay.
it goes
Yeah,
both
I
ways.
just
So it
I
can
just
be
don't
manipulated
see what
to show anything.
I just don't see why they would, continually lie like that. If there's not,
It's just
if
it's just what they do. Money
yeah,
makes their world go around. But what I really wanted to do, I've had these questions written down for a while, and I've been meaning to ask them to someone, but not many people want to
okay,
come on. Okay, so it's just basic. It's
go
just
ahead.
basic housekeeping. So you've already answered the first one, which was what shape is the Earth, and obviously you believe it's flat. And do you believe that it is stationary?
Yes.
Yeah,
I mean, I'm more sure that it's stationary
then that it's flat.
than,
Okay.
yeah.
Yeah.
I
Okay.
mean,
Yeah, that's cool, man. That's. I haven't heard anyone say that it's flat and moving yet. So if you did say that, you'd be breaking the mold. But that's fine. Um, Do you have any opinion on how far away the sun and the moon are?
I really don't like to speculate on the
But you
distances
obviously don't
to
agree. You obviously don't agree that the sun is 93 million miles away.
correct. Yeah.
Okay.
Basically the atmosphere, and the different gases in the atmosphere, like I'll say the gases in the upper atmosphere,
Yes.
um, the lighter gases, they have a different refraction value than than gases that are lower to the atmosphere.
I agree.
That's
Why? I agree with you so far. Well, why would the gases higher up have a different refractive value
well,
than down low?
it just bends light,
So,
differently.
would you call that a
And
pressure gradient?
well, I mean,
Because that's basically
basically,
that's what you're
basically,
describing.
the atmosphere is fluid. Okay, it is a fluid,
Uh,
and
yes.
and
You mean the atmosphere? You and I both agree what the atmosphere is. It's oxygen, nitrogen, all these other things. It's not. You're not arguing with that when you say it's a liquid.
no, I mean, I don't necessarily know that all the
I don't know them either, but
element. I don't know
basically,
that all the elements have been accounted for. You know,
um,
they
depends on how
they
far
give
you
us
go.
a percentage of
Yeah, roughly
every
this much of that and this
right.
much of this. Yeah, yeah. I know.
But I know from living at higher elevation that
Yep,
there's less oxygen up here.
that's right.
So I kind of
So
visualize the whole atmosphere kind of like the ocean. Okay,
I
so you
agree,
have
but quickly
the
before we get into that, just because I do get this a lot, and I just want to point out that the difference between air and water is that water is not compressible, whereas air is. So the pressure gradient in the water is not the same pressure gradient above the water. So I just want to, because that's been a real point of contention so far. So I just really wanted to clear that up before we get into it. So I'm sorry for
um,
interrupting, but go ahead.
okay. Well, I mean, I still believe. I mean, I think there's even sufficient evidence to show that the atmosphere, um, the atmosphere is on the Earth basically with only the only way it could be with as a container
Okay. Yep.
because
So you believe in
because
the dome over the firmament or
well
the dome or whatever you
I
want to call
mean it could be some kind of electromagnetic field,
it?
call it
Right.
the Van Allen belts maybe. It
Yep.
could be a lot of things, but I know that for me personally, I think about if I was to have the ability to shrink the earth down or make an earth that has a little atmosphere on it, but it's, a small version,
Yep.
and I put that into a vacuum chamber, okay, suspended in a
Yes.
vacuum chamber and start, turn it on. In my opinion, the all the atmosphere that's on the earth
It,
would remove itself from the earth and disperse itself in all through space.
that's well. you're right, but I just want to ask you a simple question. Do you think that the vacuum would suck the air?
Well, I know that, for example, inside of a vacuum chamber, if you put a vacuum chamber,
Yep.
if you put some water in there,
Yep.
okay,
It's
or
the air. Yep. Yeah, I'm aware. Yep.
and turn it on, it will actually freeze into an ice cube.
Right. So what you're saying
Or
though is if you
it will boil, not hot boil, but it'll
yes, the
boil
gas will escape from the
until
water because
evaporate basically.
yeah, because there's no air pressure to keep the oxygen. Like the oxygen doesn't have to do much work to get out of the air to detach it to become to become free. So why I'm asking is because a common misconception is that people think that vacuums actually suck, and that's not the case. So a vacuum chamber on Earth, when you evacuate it, and I know it's not a perfect vacuum, but it's close. When you release the valve for the oxygen to go back in, the vacuum doesn't suck it in. The atmosphere is actually forcing itself in to fill that void. It's not a sucking motion. It's the opposite. It's
Well,
counterintuitive, and it has been proven. It's demonstrable. And there are lots of videos. I don't think we really need to show any now unless you'd like me to.
no, I don't even think I can watch any videos right now.
No. Well, basically, just to get back to what you were saying, if you do believe that the Earth is encapsulated, let's say, with some sort of physical barrier, why would we see a pressure gradient? That wouldn't be possible if there was if everything was just pressurized. If you pressurize a container, the pressure is the same everywhere in that container.
So what you're saying is, if I got a container and I added some propane to it, for example,
If you got a
and
yeah, go
if
ahead.
I had a container like a propane bottle,
Correct.
you guys use propane, right?
Yes, but
Okay,
it's not exactly analogous.
okay, but I'm just if you had a propane tank and you
Yep.
put propane in it, you put butane in it, you put
Yep.
sulfur hexafluoride, maybe oxygen,
Sure.
inside of that container. Don't you think that there would be different layers? The heavier layers would be.
It's not analogous simply for the fact that some of those gases, when they're compressed, turn into liquids. So that's not when it's compressed in those propane canisters. So here's a better analogy. Say if I got a giant like a box the size of your living room, and I encapsulated and I closed it all up. Do you think that you could find any 2 points within that living room size box where the atmospheric pressure was different?
Well, I guess it would depend on what's inside of it.
Just the atmosphere, literally just the atmosphere. If you just got everything out of your living room right now, closed everything up, would there be a difference in pressure anywhere in there?
Well, again, it depends on your elevation.
Your elevation, where you are now.
My
is fine.
elevation.
Any elevation. You could do it at sea level if you want. So it'd be
well, I'm pretty sure it's not. I'm pretty sure it's not 14.7 where I live.
No. That's why I said you could do it anywhere. So at ocean level, at sea level, it would. The analogy still stands that what I'm asserting is that within that container, there would not be a pressure gradient. But what you're saying is that if you just make that bigger, which is what you're asserting the Earth is, you're saying that it's just a giant container that still has a pressure gradient with no acting force. Whereas on my side of the argument, with the globe comes gravity, and with gravity comes a whole bunch of other stuff. So a pressure gradient is well explained with the gravity. But we'll get into gravity in a minute. But I just want you to understand where my problem is with the container that has such a variance in pressure. And you yourself,
like I said, it could be electromagnetic field that keeps it in. As far as
sure, but there's a lot of things that come with a giant electromagnetic field that we do not experience. So,
Um,
like, you know, we're heavily reliant on electronic components, which are really
so
sensitive.
are you saying that there isn't a
That's not what I'm saying. But what I'm saying, what I'm saying is that we understand that there is an electromagnetic field. Okay, that's not what I'm saying. When I asked you what holds down the atmosphere, you
Yeah.
said that it might be that. And I don't, unless you have some sort of evidence for that, I don't think it's a very
Well,
strong argument.
there is some evidence that for a dome, I'll say. Have you ever seen sprites before?
Sprites. Can you elaborate?
Sprites. Um,
The little dots in the sky. Is that what
yeah,
you're talking about?
they're kind of, they're sort of like lightning, I guess you could say,
Mm-hmm.
except they're a lot higher in the atmosphere.
Right.
Man, I'm losing my voice.
That's right.
Except they're a little bit higher than any lightning can be, I
Yes.
guess.
But that's my problem with this argument is that it's really high up. So how does that affect the air pressure here and there?
Well, all I'm saying is you can sometimes when there's these sprites that kind of illuminate,
Yep.
kind of looks like a ceiling maybe, or you know,
I haven't seen it.
they
Let
look.
me just. I'm going to look it up. Sorry, keep going. I'm just going to look up.
Okay, let me. Okay. I'll try to find a.
What would you call atmospheric sprites? Is that what I? Would that be the right?
There's one. There's one. I think it's called something like scientists discover.
Yes, that's just backwards lightning. That's just lightning that goes up. Is that what you're saying?
No, hold on a second.
That's what these photos look like. I'm just going to let me just. I'm just going to get up the definition, and I'm going to see if you agree with what it says.
Okay.
So
Okay.
here I have, when I looked up sprites, the first thing that came up was upper atmospheric lightning or ionospheric lightning, a term sometimes
Yeah,
used.
I guess it's similar to lightning.
Yeah, so it's
just higher
yeah.
in the skies. Okay, here. Let me see here.
Sprites are a large-scale electrical discharge which occur high above a thunderstorm cloud or cumulonimbus, given rise to quite a varied range of visual shapes. They're triggered by the discharge of positive lightning between the thundercloud and the ground. See, it's just backwards lightning. I didn't know that's what they were called. The phenomenon were named after the mischievous sprite, and also an acronym for stratospheric perturbations resulting from intense thunderstorm electrification. There you go. They're normally colored reddish, orange, or greenish blue. So that I mean, yeah, that straight off Wikipedia.
Yeah, I'm not disagreeing with that.
Oh yeah.
I don't know the technical definition for it, but
So it says that they occur between 50 to 90 kilometers high. Sorry, I'll do it in miles. 31 miles to 56 miles high. So my question is how that like. What I'm asking about is this pressure gradient, because I think earlier you said that you live at about 4,000 feet above sea level. Was that correct?
76 7,600.
7,600. Sorry, I must have
Yeah.
misread that. So, and do you know roughly what the atmospheric pressure is at your altitude?
I don't.
No, that's cool.
But I just left a link in the Facebook or the Messenger.
Yep. I'll have a look now.
And it shows some picture, a video, and I'm seeing the first picture I'm seeing here is like around. Let's see. The first part's just kind of talking about NASA and let me see.
So is this a flat Earth video?
Yeah,
Lots of NASA stuff. Yep, lots of NASA stuff. I'm just looking here. Nope, here's a nice one we can talk about.
Do you disagree that there's some funny business going on some of the NASA footage?
Um, look, I'm in no way a video forensics. It's just way beyond me. There's so much that goes into it that I can't even begin to comment on things like that. What I will say is that I don't believe that all of space travel is a hoax.
You think we went to the moon?
Yes. Let me just emphasize the part where you said you think. So, like I said, I'm not an expert, but yes.
Yeah.
Do you want me to? Sorry, I found
Have
you.
you ever? Okay. Have you ever seen a funny thing happen on the way to the moon?
Have I ever seen a funny thing happen on the way to the moon? I've got your video up here of these sprites. I'm just going to play it for everybody,
Okay.
just so everyone else can see. So what? Yeah, are you saying that because this says captures the dome on video? So what do these sprites have to do with the dome?
Well, you can kind of see something above the sprites.
Yeah, right. Can you see the video that I'm presenting, or are you not able to on your phone?
How about this? Tell me
I'm
where you are.
I'm at 7 minutes and 10 seconds.
7 minutes.
Yeah.
Okay.
Right.
And is it still playing?
You just tell me when you want to click play, and we'll click play together.
Okay, go.
Right. So it's saying that they're too high above the clouds to be what we think they are. Is that it? Is that all it was? So are you saying that the top of that is
Well,
the dome?
what do you think? What would you say it is?
I'm just going to pause it here. You do realize that that's not very high. That's only 60 miles.
Well, I thought, okay, so, but it's still 60 miles. That's, the atmosphere is pretty thin at that point.
Okay, and before you brought up Felix Baumgartner's jump as evidence of the flat Earth. Now,
Evidence of non-rotation.
okay, non-rotation. Okay, sorry, my bad. And how high did he go?
128,000 feet, I think, is 23 miles or 20 some odd miles.
Right. He went 128. Yes, that's 20. Yeah, you're pretty good. It's 24.2 miles. So 128,000 feet. So how close to this dome do you have to get to see it, or is it not visible?
Well, I mean, like I said, I don't like to speculate on things that I've never been to. But
what's your opinion? I should have said.
In my opinion, it's around 73 miles over Nevada. Okay.
Okay.
Now,
yep.
I don't know if possibly the dome is farther away in different places.
Well, it would have to be, I think. But that was my next question. Is that I live in Australia, so I live on the roughly on the 34th parallel south latitude, and
I think I'm on the 36th.
Right,
here.
So it should be closer to you than it would be to me. And if I kept going south and you kept going north, how? Because here's my problem. You say, I mean, most flat earthers, and you probably agree with this, that you can't go to Antarctica, right?
I wouldn't say you can't go there.
You can't go into Antarctica. Sorry.
I would say that you can't properly go
freely explore
because of the restrictions that
Yeah.
they put on fuel and stuff like that.
Yep. No, I get that. No, 100%. So if it's 60 miles above me at if I can land on the continent of Antarctica, that's not a problem. We both agree with that.
I
How much
I
it
said
would only be, and here's my assertion, and I'm just playing the devil's advocate here, but wouldn't it have to be extremely close to me?
well, the thing is there could be different layers of the dome, you know.
Yeah,
Um,
but you
oh,
agree that it's a physical thing, this dome. Is that what you like?
um,
And that's why space travel is impossible and all this kind of stuff.
well, personally, I think that space travel, well, technically space is 50 miles, right?
Uh,
That's what NASA considers space, the boundary of space, the
okay, well
farthest line.
let's rephrase that then. Going to any other
But
object in space. Let's say that.
okay, like the moon, or yeah, okay, so out of the Earth's, well, I guess the moon is supposedly in Earth's atmosphere now, but
Well,
um,
what you classify as the Earth's atmosphere and what they classify as the Earth's atmosphere, I think, are going to be completely different. So we don't have to take that
yeah,
into account.
probably. But here's the problem that I have with space travel,
Hmm.
is the once you get to a certain height, once you get to a certain elevation, the atmosphere is so thin, okay,
Yes.
that I know the whole argument of the Newton's third law, that
Yeah. Equal and
says
opposite reaction. Yep.
right,
I'm
okay,
following. Yep.
but my contention with that is that when the when the rocket is in our atmosphere, it is pushing against the atmosphere, okay,
Okay.
and this is the evidence that I would present, in correlation with that, is the different types of nozzles, the different types of nozzles that are used for different elevations. Okay, so in other words, higher elevation rockets have wider nozzles because the propellant comes out at a different angle that utilizes the most surface area. Okay, surface area of atmosphere.
Hmm.
Okay, and so and also when you see rockets, when you see like the older style rockets that go straight up before
Yeah.
they started making before they started making it a parabola, an
Yep.
arc.
Yep.
There's ones that were going straight up in the air, and you can see those ones once they get to like 65, between 65 and 70 miles. They get to a point where the rocket almost acts like one of those rockets that they build that are too heavy, that doesn't have enough thrust on the ground, and they kind of just they lift off for just you know 50 feet or less, and then um, they kind of just tip over and spin horizontally and blow up. Okay, now the old rockets, you can see they get up to a certain point and it's like they lose they don't have enough thrust to to continue the rocket going, and the rocket tips over, flips horizontally,
Yep.
and just kind of corkscrews until and this is still with a whole bunch of propellant, and the speed of it was still, it was still going really fast. There's no reason that the rocket should have just deviated and started flipping horizontally like that.
There,
Um,
well,
it's almost
there are a lot of reasons, but um,
well,
what we said at the
I've
start of
I've
this is
seen,
that you said that you knew what Newton's third law was, and
yeah,
I think a lot of people
basically,
actually misunderstand it because this is how I understand it, and you can correct me if I'm wrong. But for every action, there is an equal, and that's in the size or the magnitude, and opposite, and that is in the direction reaction. So you have an
right,
equal power and an opposite direction. So on Earth, once you leave the atmosphere or start getting into the thinner parts of the atmosphere, which we both agree happens, it's not as hard to move through, basically.
That's the theory. Like I said, I know the argument.
Yep. So what a lot of people say is that Newton's third law says you need an equal or opposite reaction. That's how a lot of people. So I'm just making sure that you're not making that mistake.
No, I'm basically okay. Imagine this for a second. Imagine you hooked a parachute to the end of the rocket. Okay,
right.
a non-flammable parachute.
Mm-hmm.
Okay, just imagine if it was possible to make one.
There's one of those in space. A big parachute in space. Bill Nye put it in
right.
space.
But I'm saying one of the ones that slows rockets down.
Yep. Yeah, I'm with you.
And this one actually
hung behind the rocket.
One actually would deploy as the rocket is actually taking off. Okay.
Yep. Ascending. Yep.
The rocket, the propellant coming out would still be the same, right? The only we could say, even if it's above the atmosphere, say it's 50 60 miles,
right.
and they deploy this thing that's fairly close to where the propellant's actually coming out.
Yes.
Even though the propellant is still coming out, the parachute, maybe that's not the best.
Here's one. Let me try this. How about this? Let's just say that space is real. Okay, I know you don't agree with me, but let's just start there. And now I get an elephant. Okay, there's an elephant in space. It can breathe in space. Don't ask why. And I attach a spring to it, and I pull that spring back, and I put a 1 kilo weight on the other end, and I let it go. What's going to happen?
If I'm understanding you correctly, all I want to know is if the spring still works in space. The spring would still work, but that's kind of like a mechanical. That's more of a mechanical device.
That's right,
as
because
opposed to something that's okay. Here's an example.
All I'm trying to point out is that the laws of physics still work in space. There's no reason that they shut down all of a sudden because you just go into a different. They still work.
Well,
like there's
here's the thing. There's a little example that they'll tell you can do, where you get a straw, right, and you get a balloon. Have you ever seen this on a string? Have you ever seen this? Okay, so you take the balloon, hook it to a straw, and put the straw through a string through a straw, a little string, and then you blow up the balloon on one side, and you can let it go, and it will thrust to the. You following me?
Sorry, you cut out there for a second. It'll thrust to the what?
Headphones get unplugged. So you take a straw.
Yeah, it's in the balloon.
Hook a balloon to the straw.
Yep.
And then you put a string through the straw.
Right.
And you blow the balloon up on one side of the room, let it go, and the balloon will fly to the other side. Kind of like a rocket does, even though this one will be guided. This would be guided.
Okay.
This is guided with a string. Okay. So if you were to hook another piece of paper onto the back of the balloon,
it wouldn't self-propel.
The air blows onto the paper and doesn't go anywhere. It just kind of, even though the same amount of air or propellant is coming out the one side, it still doesn't propel the the balloon to the other side. You understand?
But that's because the paper is now part of the system that you're trying to propel. So you can't, like, if we could create something that propels itself perpetually, then
Okay,
it would
here's
just.
another example.
But
Here's another example.
here's a
Here's
better.
another example.
Okay, but I just want to ask you one question. What do you think happens? Like, let's just, again, you have to imagine that space is real, but
I think this. I think that everything, whether it's a boat in the ocean and it's propelling off the water, whether it's someone swimming, whether it's a bird flying,
yes,
whether it's
they all do work.
every
That's right. I'm with you.
everything is pushing against the air that's around in order to, even the rocket when it takes off, it
What
push
about when you lift
the
something off the ground?
when you lift something.
Yeah, are you pushing off the air to lift it?
Are you pushing off the air?
Yeah,
No,
unless I misheard you, you were just
your
saying that.
feet would be on the ground,
Yeah.
and so you'd be pushing against the ground, right?
Yeah, so there's lots of different ways for work to be done. You don't have to push against something to get a reaction. But my question that I wanted to ask you was that if a rocket was to go into space, and let's just say there is this combustion flying out of the back, what would be the equal and opposite reaction of that?
Well, if okay, if it takes off in the atmosphere,
Correct.
it's pushing against something. Once it gets out of the atmosphere, it's not pushing against anything,
But
so it's not going to be able to go anywhere.
Okay, but I'm asking. That's not what I'm asking you. I'm asking you what the equal in size or magnitude and opposite in direction reaction would be to the propulsion of the rocket. What would be the because everything has to have an equal and opposite reaction. That's the whole idea. That's your argument.
That's what I'm saying is once a rocket gets up to that elevation, it just spins out horizontally because that's the least amount of resistance that's.
Well, the least amount of
possible.
resistance is in space. Is literally once you get into space, it's extremely.
Well,
it's very easy once you get out of low Earth orbit to move around because there's a lot less net forces on you. There's always gravity, but it's not. Taking a rocket off from Earth, launching a rocket from Earth, requires a lot of energy. If you were to do that from something half the size of the moon, it would take barely any energy. But my question still is everything.
I haven't seen enough evidence to convince me that that anything is going past past a certain distance.
What do you think of Red's video? I'm assuming you've seen Red's video where the gas that is evacuating out of the back of the rocket just starts to expand exponentially when it gets to a certain height. Now, you've already said that if you put gases into a vacuum, that they will expand rapidly to fill the space, and that's exactly what we're seeing there. And I just want to get your take on that because I think that's.
Well, I haven't seen anything specifically.
It was in that video that you linked to me. It was actually part of that video. I can give you the timestamp if you want.
I honestly hadn't even seen that video. It was just the first one with the.
Oh, okay. Yep. Well, how about this
title?
I'll give you.
Put it into the messenger, would you?
Yep. I'll just give you the. I'll just get the timestamp for you, and then you can have a look at it yourself because you agree that when gas is released into a vacuum, it expands at a rapid rate to fill the vacuum because that's what gas is, pressurized gas. So let me just get this timestamp. Give me 2 seconds. So that's at 5 minutes and 5 seconds. That's just the same video you sent me.
Oh, okay. Let's see.
Yep. So just go to 5 minutes and 5 seconds.
Okay.
And then watch from there, and you're going to see the gas from the back of the rocket expanding. And I want to know if that's a vacuum or if it's something else, or what you can explain it as.
Well, I think the definition of a vacuum is just the lack of
anything.
right. So, I mean, I'm not arguing that up high in the atmosphere that there's or it's either very few particles or particles that we can't detect or haven't detected or
Well, that's
don't want to detect.
well,
Right?
that's a pressure gradient then. So you agree that there is a pressure gradient?
Well, I mean, I guess you could call it a pressure gradient.
Well,
Like I
what else
already
would you
told you.
like? What would you call it if it starts at 14.7 psi and then eventually gets to hardly any particles near vacuum? If I'm using the wrong terminology, I'd like to know, but I think that's pretty fitting for what we
Yeah, I
experience.
mean, I'm not arguing with the terminology. I'm just basically saying that, I haven't been up there. I know
And look,
that
not many people are going to go up there. So what you have to do is you have to observe from the ground, and you have to take
right.
what you know
Well, there's
and
a
do
bunch
experiments.
of videos of rockets hitting I don't know
Well,
what it is, maybe
so
some other kind of uh gas
here's
or
the
some
thing:
it looks
when a
like they
rocket,
splash into water or something, but
what are you talking? What sort of rocket are you talking about? Because I've seen a lot of
um
amateur small rockets doing that, but I haven't seen any
it'd be it'd be like the SpaceX Falcon
Falcon Heavy. That's
Falcon
nice.
Heavy probably was one of them.
Hitting a barren in
Um
the sky.
I'm not exactly, but I know they were SpaceX rockets, but I'm not SpaceX, supposedly sends a whole bunch of different uh payloads out,
Well, they do, and it's absolutely amazing that they're doing it. I think it's just yeah, it's just it's crazy. But so I don't want to pin you down or anything, and I'm not trying to trick you, but I just really want to. I feel like you and I both agree that we have a pressure gradient, but I just feel like you don't want to say that. Like
No, I think that there's pressure. I mean, there's definitely pressure. I can feel it when I go up hills and
yeah,
stuff. I mean,
100%. So, but,
um,
but as you go higher,
but
there is less pressure. So we've already agreed to
I
that.
also, yeah, I also believe that all the atmosphere couldn't be held on by the puny little Earth's gravity. Well,
Now, when you say that, it's yeah. I mean,
I say puny because the sun supposedly makes up 99.98% of all the matter, all the mass in our solar system,
yep. That's why
which
everything
le-
orbits it.
which well, which leaves the Earth puny. Okay.
It is. It is absolutely tiny. Have you seen? Have you? You
Okay.
know what? I'm going to show you a photo of the representation of how small the Earth is compared to the Sun, and then
No,
you.
I know.
Yeah.
I,
Well.
Trust. I know all the official.
Yeah. Well.
All the
I just.
official numbers and the scale size, and the sun is supposed to be 93 million
Yeah.
on
Yeah. 100%. So.
average.
So
Um,
Earth's gravity is quite small compared to the Sun,
Earth's
and that's why.
24,901 miles in circumference. They say. um,
So. So that's why
the
everything in
moon's
our solar
the
system
moon's 2159.
orbits
Yeah, I
the
mean,
Sun. So So I agree with
I
you that
don't.
Earth does have a small gravitational field, or but that doesn't mean that it can't hold down large bodies of water, because a constant acceleration of 9.8 meters per second is the apparent force that we get from the warping of space-time. Now that's I know yeah, I knew you were going to chuckle there, which is
It's like
what's yeah.
it's almost like a religion.
I hear that all the time, and I think
Because a lot of it is you have to have faith. You have to have
what
faith.
exactly? So let's just see what you disagree with here. Do things on Earth accelerate at 9.8 meters per second squared?
Well, I wouldn't agree with that.
You wouldn't agree with that.
I would say that it hasn't been sufficiently. It hasn't been sufficiently. It can't. There's no possible way to
Careful.
to sufficiently test it, because
test the acceleration.
I'll explain. You can put something in a vacuum chamber, but how big is the vacuum chamber? Okay, so
Well, how big does
in
it
other
need to be?
words, well,
You tell me.
there's such a thing as terminal velocity,
Not in
right?
the vacuum. Terminal
Well, but
velocity is when the drag from the air
how
resistance
big of
meets
a
the
but
equilibrium of
okay
the force of gravity accelerating. So there is no terminal
okay
velocity.
so where in what vacuum chamber was that tested? Do you have any
So do you want to do it right now? We could find out the frame
well
rate of a certain video where they drop them in a vacuum, and we can measure the size of the
no
object.
okay, but do the objects get
that's something we can do.
do how fast are the objects falling?
Well, we can figure that out.
No, but I'm saying, okay,
They're
terminal
accelerating.
velocity. Okay, right. I understand.
Okay.
Terminal velocity.
Yep.
Okay, in the regular atmosphere
Yes.
gives a certain value. Okay, depending on where you're at, probably, I would imagine.
It depends on your surface area, your mass. It depends
Right.
on a lot more than just the location.
Right, but what I'm saying is, for example, I already said to Felix Baumgartner jump. I'm going to go to a rocket launch instead. Shuttle launch, or even the Blue Origin, the Blue Origin rockets. Have you seen those?
Can you pick
No?
something that you know the dimensions for? Is that
Okay.
possible? Or
The dimensions, like the size of the rocket, or
yes, yes,
the
the size and the weight
well,
and whatnot,
I
because
don't
we can
I don't
calculate the
have
terminal velocity of things.
okay. I don't have those exact numbers right in front of me, but I know that, for example, there's a couple shuttle launches that I've been watching recently that they have two engines, two rocket engines that that, um, that detach or eject, or let's see, that's not the right term either.
Abort.
They you say
Is that
abort?
is that what you're talking about? The abort tests that they've been doing?
No. This is just a regular when they still had the shuttle. Okay, and they would send the shuttle up, and they would have two solid rocket booster engines that detach before the main tank detaches.
So
Okay,
the SpaceX.
and then no shuttle.
Oh, shuttle. Sorry. I'm trying to look something up at the same time. My bad.
Okay, so the shuttle, the two solid rocket booster engines detach before the main fuel tank detaches. Okay, and then the shuttle flies on. Okay, but when these booster engines are falling back to the Earth, they get up to like free fall speed of 2,600 miles an hour,
Yeah.
and then as they come into the atmosphere, they gradually just get slower and slower and slower.
Right.
Okay, they slow all the way down to around 300 miles an hour before they deploy um, before they deploy the drogue chutes and all the different, you know, chutes to save the rocket.
Yep.
Man. So you understand what I'm saying, right?
Yes.
Okay. Going horse. I'm not used to. I'm not used to talking to people this late.
That's all good. I'm actually just going to
Um,
send you a link to it's. I just found a neat little tool so that you can actually calculate the terminal velocity for something that you have the known dimensions for, and you'll see that
okay.
the gravity. You'll see that gravity is accounted for in that. So it's. So you can muck around with that later. You don't have to do
No,
it now. It's not.
I understand, but here was my point. This was my point.
Okay. Go ahead.
My point was that these rockets, and I've seen, like I said, the Blue Origin rocket, same, pretty much the same story. It gets up to free fall speed of like 2,600 miles an hour, and then it slows down to about 300
Yeah,
before it
because
shoots out it.
it's encountering more drag. So
Drag,
yeah,
drag.
that's right.
No, I understand.
So
I
that's
understand that. But
okay.
what I'm saying is, if you were to drop something from say 40 miles up with no atmosphere in a
Yep,
vacuum,
you wouldn't have any drag.
r- you're jumping to conclusions of what I'm going to say now.
Okay, carry on.
Um,
Go ahead.
is would it really keep on getting faster? That's
Yeah.
my question,
Okay.
and I don't think it's been sufficiently tested
Does
as
it?
far as drop you, because you can't,
Okay. Let me
because
answer.
there's,
Let me answer. 40 miles is really high, so that's probably why we haven't. But let me answer here.
yeah,
So,
yeah.
to my knowledge, and this is just me, and I'm happy to be wrong if someone wants to correct me. But yes, it will keep accelerating, and
But
that
is there any way to prove that though?
yes. Do you know what okay. So small scale tests have validity. So if you want to test something that's 40, you want to test the 40-mile. What do we really need to go and make a 40-mile high vacuum chamber to test that?
No, but
No.
if you, okay, if something
It,
gets up to
if
terminal
it,
velocity in say what, 1,000 feet,
yeah, but
or
here's the thing: a feather can get to terminal velocity in a lot less because it won't fall very fast. It has a large, I'm not sure if this is the right terminology, but it has a large drag coefficient. So it it has a lot more drag on it, less mass. So its speed isn't going to get faster as it comes back down to Earth that
so
much. So
what what
if you
causes
dropped a feather from 10 feet high outside of a vacuum and then inside of a vacuum, would that not be a six? Would that not be a test that you could take usable data from?
you could get usable data, but it's not gonna tell you if things actually
Why not?
continue to speed up
Why?
past terminal velocity.
Okay, so the acceleration is
I
9.8
understand
meters per second squared. Okay, so just bear with me for a second. That's 1 meter, 9.8 meters per second, right?
per second,
Yeah,
right?
that's right.
Yeah.
Okay. So how many meters would you have to see that acceleration for you to be convinced that it would continue accelerating? Or do you want to, like, because what you're asking for is something that's unfalsifiable. You want to see something accelerate to
Yeah. Well,
infinity,
I mean,
which is not going to happen because there are things, nothing can go, there's constants, nothing can go faster than the speed of light. And like I said,
no, I understand.
I'm probably wrong about whether things accelerate indefinitely within a
But
vacuum. But
in a theoretical world, okay, if you were to drop something and it's going to continue getting faster and faster, then
right.
that means that it would eventually have to exceed the speed of light. Don't you think?
Well, yeah, hypothetically, that's as I understand it. So what's the problem with that? I
Well,
don't see the problem with what you're saying. You're asked
well,
why we haven't dropped anything from 40 miles high inside a vacuum, which is really hard to
that's
do
not
because
that's technically not what I said. I said that it's not really provable,
no,
and
but
it's not really
you don't need to do it from
provable.
40 miles. You can scale almost everything except for gravity. You can't scale the force of gravity. So the force of gravity is a constant. It's called the law of universal gravitation. So you can scale everything else. You can scale the distance it falls, the object, the atmosphere, the medium, whatever you want to call it. But you can't scale gravity. So it
Well, I guess we don't really live in a vacuum though
no,
either.
I hear that all the time. But believe it or not, what you do in a vacuum is you're taking out. So I hear density and buoyancy all the time. None of that in the vacuum. So that's out of it. That can't be it. You remove a lot of variables when you put things into a vacuum. So what you're left with is an apparent force that it doesn't manifest physically. So you know,
What do you mean? Because basically, okay, everything's located on the ground already, right?
um,
Besides for possibly meteorites, or things that on your model could come from space, or my model could come from the container that's above us. But
uh,
my point is, everything is located on the ground in nature, right?
Um,
With
okay.
with sufficient mass is located on the ground, right?
What?
Can you name something that's
It's not
that's
located on the
not
ground?
not a gas,
Okay.
that's not float, so anything
Okay, so okay, here
with
you
a
go. Everything.
sufficient
Okay,
mass
okay,
that's not connected
okay.
to the
Here, I'll give
ground.
you this. Okay, everything that is on the ground is on the ground. Yes, because that's
Okay, well,
yeah. I mean, I'm not sure what you're asking.
everything with weight that's heavier than the air around it is on the ground naturally, right?
Um, and why is that? Can you explain that to me?
Because of its weight.
Okay, but can you
Because
weight
it
is weight
weighs more.
weight is a byproduct of gravity. So
Well, okay, no, actually, gravity is a byproduct of weight
okay, so
because
how about this? How about this?
if
If
you
I
wait,
took a
wait, wait,
scale,
wait, don't interrupt me. Let me finish, okay? The gravity comes from Latin gravitas, meaning literally the definition is weight or heaviness. Okay, so so you
okay,
kind of
so
have that backwards. You kind of
no,
have
no,
it
no, no, no.
backwards.
What you're doing here is you're conflating the idea that a word came before an understanding. So they called it the sun when they thought it was a god or whatever. They had a name for it, but then when they understood it better, they didn't change the name. That's the only thing. So it's not. And here's what I was going to say earlier when I rudely interrupted you. I'm sorry for that. But if I was to take a scale into a vacuum and weigh something into a small vacuum, and I took a 1 kilo weight, weighed it outside, weighed it inside, do you think it would weigh anything, or do you?
Of course,
Okay, so
because
it's obviously not
because
density. It's not the density of the medium
it's
around it that gives it its weight.
no, it's density is equal to the mass over the volume
Yeah.
of
Okay.
an
So
object. And you weigh
so
that in grams. Gravity doesn't even play a part in calculating the.
so what's
You can find the density. You can find the density if you have the mass and the volume, and you can find the mass if you have the volume and the density. There's a triangle. It's
yeah? I know
called.
how. But yeah, the most formulas can be worked backwards. But my point is, when I said why is everything on the ground, you said because it's heavier than the air around it.
Yeah, and
Yes,
it's
so that's
naturally located. It's naturally located on the ground. Why would
why
you
the ground.
expect for it to?
Like why
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 would
is it directional? Why is this force that doesn't exist directional on a flat plane?
because it's located in nature, on the ground already. Why would you expect for it to go any other direction than where it came
That's
from?
but what about a tree that grows up and there's an apple on it? That's located in the air. Why would it go down?
Yeah, it grows. It gets nutrients from the ground
So it
and
wants to go back to
soil
the ground.
from the water. Yeah, it returns to where it came from.
Um, I'm really not satisfied
Leaves,
with
leaf.
that.
Well, I mean,
It's just
that's
that's kind of
that's
like
okay.
it's just kind of
That's
like,
okay.
well, I don't know, but this is like it's
Well, that's.
that kind. God.
I think I think it's I think it's a lot more simple than I think it's a lot more simple than what it. Okay, here's another point.
Well, that's a really simple
S-
explanation, but I think it's like
here's another point that bothers me, and I know you'll have a rebuttal for it, and I already know I already
maybe
know the argument. I already know the arguments, but um, objects with a different mass. Okay, let's say let's say a bowling ball and let's say a styrofoam ball. Okay,
yes,
they both have they both will fall inside of a vacuum at the same rate. Okay.
they will.
Okay.
Well, sorry, just to clear it up, they accelerate at the same rate. Yes.
Okay. Okay. All right.
Because
So
an acceleration
they
requires a force, and that's
they
why
ex
you need to be clear.
they well
Well,
they
name one other form of accelerate. Like, show me something that accelerates without a force, and I'll agree with you that it doesn't. But there isn't anything, so I think we can both agree that that is true.
well I can agree that objects fall down. I mean, I'm not saying that it's a magic force or a hidden force that we can't, you know.
It's
I'm
not
not saying
magic.
that.
It's.
It is
I've.
kind of magic. I mean,
It's not magic in any way. It's a lot of stuff that we do is dependent. Like GPS, for example, is dependent on our understanding of gravity and our utilization of gravity. So if something was
the
magic, couldn't we
GPS
just oogly boogly and use a wand and then just everything happens? No, we have to do a lot of work to utilize it. And
GPS. Okay, go ahead. Sorry.
I think it really detracts from the people that do all this work, and to just say that it's not real and everything's fake. I think that's a big part of my problem with this is people people have lived and died doing this, and then there's this wave of people that just go, well, none of it was real. I find it just so extremely.
You're talking about space travel?
I'm talking about the people that put satellites up into space. I'm talking about all these people that you basically. I'm not singling out you and saying that it's you in particular. I'm talking about the community as a whole, and they're just pointing the finger at people, at communities, and at professions, and just saying that it's all fake. And I think that's the biggest problem. And I think that you don't just to say, oh, satellites don't exist and it's all ground towers or whatever. What about all the people that worked on the
now
satellites?
You're kind of okay. You're just giving an example because we haven't talked about satellites, right?
You were getting into it, and I was just saying that we use gravity all the time. It's not magic. We know how to use it.
I believe that there's satellites but they're not.
You're not a balloon-like guy, are you?
The satelloons.
Satelloons, yeah, satelloons.
Are you don't think satelloons exist, or what?
I think that satellites exist. I didn't say that satelloons don't exist, but I don't think that. I think that the amount of footage there is of satellites in transit it speaks for itself. I don't think that
satellites in transit. Are you talking about like the Starlink or which ones are you talking about?
Well, I have an app on my phone. I'll actually send you a link where you can look and find the satellites, the maps of the satellites.
No, I know. I've done it.
So.
No, I've tracked them. I've already proven to myself that they're not what they tell us they are. For example, okay, a year and a half ago, maybe it might have been 2 years now.
Yep.
I was tracking the ISS. Whenever it would come by, I had the ISS tracker, and I had several different other, satellite notification applications, and it notified me that there was going to be it was called Iridium 77. Okay, it said Iridium 77 was going to be going by in 10 minutes or whatever. Give me a little bit of time. I went outside and set up a pretty high-powered spotting scope in my backyard, and it tells you where you're going to see it in the sky. Okay, right. It was and it was accurate. It was accurate. It flared for about 7 to 10 seconds, I'll say, and during that time, I was able to get the scope trained onto it, right, and so it flared for about like 7 or 10 seconds, something like that, and when I saw it, it looked just like a flashing light, kind of like what the cops would have, or a tow truck, amber and white, or maybe just amber colored, flashing, kind of like a cop car light.
Okay.
It's how I would describe it. And there was 2 objects. Okay, there was one in the front and then one a little bit behind it. Okay, a little bit spread out. Only one of them lit up, but I could tell that it was the same object because it moved a little bit. Sorry about that. It moved a little bit, but it didn't move. It didn't move like a satellite. How I would expect a satellite to move. Okay, because it was saying that it was going. I was watching it and I was like, "Whoa, this is cool," because now be able to know how far away I can see into space or whatever you want to call it.
Yeah. What
I'll
was
know
the
how
distance? Do you remember?
the distance was. I think it was only supposed to be like a 450 kilometers, or I
Kilometers
could
or
be wrong. I
miles?
could.
Do you remember?
It might have been miles. It might have been miles actually. I don't know why it would be in kilometers,
Yeah,
but
that's.
actually, it might have been in kilometers though, because I could be wrong. I looked it up the other day, and it's decommissioned now. It says, and and it tells you how high it was supposed to be and stuff. But so I'm watching it though, but I'm thinking to myself, this is cool. I'll be able to know how far away I can see, like how far away I can still see that
Mhm.
satellite, because it tells you where it's supposed to be, approximately above the Earth, right? And so I'm watching it, and it's it's not really moving, like it's not really moving towards the horizon down. It kind of moved up and to the right and down and to the left, and kind of
Okay.
just moved around. It kind of moved around like that. It wasn't like a plane flying away and it gets closer to the horizon, and then
Can I ask
it
a
kind of
quick
just.
question? Just about
Yeah,
what
yeah,
you were using to view it. Did you have it on a tripod with some sort of a
yeah.
tracking system? Did you have a tracking
Uh,
system?
n- no, no, it
Okay.
was just by hand.
So I've just looked it up.
Um,
It was 485 miles. So
see, I mean, I knew it was. I wasn't too far off, right?
no, that's all right. That's all right. You just had
Okay, so
you had it in kilometers. That's all. So
I said kilometers, and I thought that would
um,
okay, but it was 400 and something like that. Okay, so anyway, I'm watching it, and now it says it's going over the North Pole, but I can still see it good. Okay, it
okay.
says it's going over the North Pole.
Did it
Okay,
say it was going
and
over the North Pole or visible at the North Pole?
it said it was going over the North Pole.
Hmm.
I think it was some kind of a polar orbit, or okay.
Because
So
at a
oh,
distance, as far away as it is, I can't. Yeah, I mean, it's.
will you let me finish?
Sorry. Yeah, go ahead. Go
Because
on.
if you don't let me finish, it's okay.
I'm just
So
trying. I'm just waiting for you to get to the point because I think so
well,
far what you've done is seen a satellite. So it's
okay. I'm getting to it. Okay, I'm
all right.
getting to it. You just gotta let me get there. This is how I try to help you visualize what was going on. Okay, uh, from my point of view.
Yeah, I just
If I just
little bit short on time. That's all. So I was just sorry.
okay,
Yeah, sorry.
okay. So so it said it was going over the North Pole. The app crashed. I reloaded the app, um, and it no longer had Iridium 77 on the list of active satellites. So I went to it was a NASA slash Air Force website it's not up and running anymore. It just gives you a message that says this website is no longer something or other.
Mhm.
but but so I went to this website, and I relocated the Iridium 77, and it said, by the time I got that up, it said it was over the Indian Ocean, right at this, you know, it said it was directly above the Indian Ocean, and but I can still see it. I can still see it, and it's moving. Like I said, it's going up a little bit, to the right, to down, to the left. It's kind of just hovering, sort of in the same place. Okay, and I watched it for 50 minutes. It was I started at like 3:20 in the morning, and I watched it until 4:10 or something like that. I and the only reason that I stopped watching it was it was starting to get light out, and the mosquitoes were coming out, and they were chewing me up.
Mhm.
Okay, I so after that I came inside, made something to eat. Okay, It was going to take 20 minutes. It was a pizza, just a regular DiGiorno pizza or whatever. And I put it in the oven, and I came and I sat on my couch, and then the app notified me that Iridium 86 was going to be flying by my location in 10 minutes. Okay.
Yep.
And
Is
it
that the
showed me
same satellite that you viewed? Is that what you're saying?
it showed me the place where I was going to be able to see Iridium 86, and I pointed my phone up to it, and it was in the same exact area
Hmm?
that this Iridium 77 was in for the last hour.
How far apart were
So
those viewings?
how far apart were the viewings? Is that what you
Yeah,
said?
like was it over an
It
hour?
would it would have been an hour and 20 minutes, or an
Yep.
hour and 10 minutes maybe.
So I'm not sure if you're aware, but Iridium 77 is actually it's a group of satellites that does 100-minute roughly. I think it's 100 minutes. Let me look it up. But it orbits
No,
north south
that's
pole.
that's that's not the Iridium. The Iridium class satellites
Yeah, it's a
are
constellation.
are no,
Yeah.
they're. I'm not. That's not my. That's not what I'm saying. They have their own designation.
Yes.
They have their own number. Okay,
Yes.
Iridium is a group of satellites. I'll agree with that. But the um, but they have their own names. They have
That's
their own
right. Yeah,
numbers.
that's right. So they fly in groups of.
So like I was saying, it was Iridium 77, and then it changed to Iridium 86
Mhm.
within, it was right at the same time. I mean, I had just came in and sat down, and it said Iridium 86. I pointed my phone up to the where it told me to, and it was in the same exact place that I'd been watching Iridium 77 for the last hour.
Yeah.
So, and like I said before, it looked like a flashing light. So, so
So what
what it
what?
looks like to me, what it looks like to me is they have these weather balloons satellites up there
Right.
that are able to drop down. They they fly around in the wind currents. The wind currents at different elevations are blowing different directions. Okay.
Yeah. I
And so
thought that
they
was
they drop down. They have a ballast on them that, and during the daytime the balloons want to rise up higher and lower. I mean, they're huge balloons. Okay, they're like 660 feet in diameter. Okay, like huge. Some of them, no, not all of them, but some of them are huge balloons, and they're only like 25 miles up or something like that, and they're as big as they're as big as a football stadium.
okay.
Okay.
So how now? Here's my question. I thought that was where you were going, and I'm sorry for interrupting earlier. But if
And my
if
point is you think you can see satellites for like dish TV or stuff like that? You think you can see those satellites, which are actually pretty small? The one for dish is actually the biggest one. But 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 relatively, in comparison to these balloons, they're relatively small objects, and really supposed to be really far away.
yeah,
And and you think that you can see those small, far away objects, but these balloon satellites that are much larger and closer, we don't see those commonly. Like, I mean, we see them sometimes, but it's not like a common occurrence to see them floating around. You know what I mean? And
yeah,
so I guess my point is what makes you think that you can see those objects that are so far away and a lot smaller, but you can't see these balloons that are a lot closer and bigger.
Right. So I have a couple of questions here.
Okay.
Firstly, how fast do you think that satellite or balloon or whatever it is you saw was traveling?
Not very fast.
Not very fast.
Probably not very fast. But it said it was supposed to be going 17,500 miles an hour.
Okay. So I've sent you a link to a lunar transit of an Iridium satellite. So now I want you to watch it, and I'm not calling you a liar, and I'm not calling this guy a liar, but these are both claiming to see the same thing, and he's captured it here, and it's moving very quickly. So I just want to get your thoughts on it, and I'm going to present it to everybody in a second.
Well, it'd be nice to know possibly the timestamp that this was taken.
Yep, 9th of June at 4 a.m. on
At 4 a.m. Okay.
Yeah, in 2012.
2012. It looks like it's moving pretty fast.
Like I said, I'm not trying to like sharpshoot you here or anything, but I just I just looked up the footage trying to find what you were talking about, and I've found it, and it's kind of speaks for itself, I think. Let me just present that to everybody.
That video kind of ended abruptly, but I don't know. I don't know what those things are. I mean, basically, you see how it kind of towards the end it kind of it starts getting really, I don't know how to explain it. How the rays of light are kind of it seemed like the moon just lit it up, huh?
Yeah,
is that reflecting moonlight?
You would expect something as bright as the moon to overpower that. Oh, do you mean at the end? Is that what you're trying to say?
Well, at the end, right around
about 53 seconds.
I'm watching a different.
That's what you're saying.
Yeah. Well, from not necessarily the flare part, but
just at the end where the light rays are reaching outwards. Is that what you're saying?
Yeah, I don't know.
I wouldn't.
I mean, I guess I can't. I don't really have an argument for.
That's fine. Like I said, you don't need to. You don't need to. I just wanted to show you that that footage is there. So that's 7 years old. That footage, and that was. There's no reason to call that person. Say that they're being dishonest or anything like that. So.
You see how it? I just watched it again. Do you see how it? You see how it flips right? Okay. Okay. 20. Go to 20. Go to 25 seconds. It played for 25 seconds.
Where the camera focuses on the brightest object. Is that what you're saying? So you see how it focuses on the moon, and then it tries to focus on the satellite again, but it doesn't actually get back into focus for the rest of the video because the moon is so bright that the camera's sensor.
Oh, hold on. I'm gonna slow it down. I'm gonna play it in a slow speed to because it kind of looks like the moon is in a different orientation. Like the lit part of the moon is in a different orientation. And then right when it gets close to it, it seems like it switches. I could be wrong. Just
let me see.
It kind of like turns. Okay, okay.
I can play it frame by frame if you like.
Okay. Well, I guess it could be just the way that the camera is reacting to the exposure, I guess.
Yeah, I mean that would be that's the most sensible explanation for it. So I can't think of any reason why that would. Yeah. So what are you trying to say? That maybe
I don't know. That just looks really weird. If you slow it down,
I'm doing frame by
slow it.
frame. I'm at 27 seconds just before it passes in front of the sun, in front of the moon. Sorry. You see, you can slow it down frame by frame. You can see that nothing changes. Just what the camera's doing is adjusting for the light conditions. The moon.
Well, I
The
don't
moon
know.
looks beautifully spherical, by the way.
It looks spherical, is that what you said?
Yeah.
I don't know. I don't know about that one. So
yeah, that's just that's out there if you want to have a look at it and you can make your own observations and compare. But what he was using is, do you want to know what he was using? And that's why I asked you what you were using when you were imaging. So he's got a full write up here, and he's actually imaged a lot of these satellites. He has a whole website for them, which I'll send you the link for right now. So you have a look at this, and I think it's a pretty reliable source. And if there was a balloon attached to it, you would see something when it passes in front of the moon. That's my point.
yeah, I agree that's not a. I mean, if the footage is real, it's not a balloon. It's not on a balloon. But I don't know. I don't know the exact technology that we have. Like
Oh no, look.
Stuff stays classified for a long time. Really fast airplanes and stuff like that. They're classified, so you wouldn't even really know.
Oh yeah.
If they had something that was super fast, like a super fast drone or something.
Here's the other problem. Like that satellite is said to be, what did we figure out? 480 miles high in altitude. So that either has to be beyond the dome or it's not that far.
Well, I don't think it's. I that far.
How about this? If it was closer, do you agree that if it was within 80 miles, like you said, the speed at which it would be traveling would be ridiculous?
Well, not necessarily. I mean, something farther away is going to seem like it's going slower than something closer.
But, yeah. So
don't you think?
Here's the thing: is
how many times have you watched the ISS, for example? How many times have you
with my
seen
own eyes?
ISS? Yeah,
I live in a pretty high light pollution area, so probably with my naked eye, I've observed it probably 6 or 7 times.
And how long would you say? I've timed it personally, but how long?
Oh, I couldn't even tell you. I couldn't even tell you. Yeah, no, I haven't. I can.
But you should be able to tell me from horizon to horizon. If you're, I'm assuming there's not a lot of mountains where you live.
I actually live right next to mountains, basically.
Oh, do you?
Well, it might be way too much, but.
Well, okay. So I know for me personally, living at 7,600 feet and still having mountains. I have mountains that are up to 12,000 feet within 10 miles from me. To the east, to the east, and to the southeast, I guess, and to the north is mountains. Okay.
Yep.
But usually when the ISS goes by, it either comes from I've seen it come from the south. I've seen it come from the south and go north, northeast, I guess. And I've seen it come from the southwest, or from the northwest, and go basically southeast. Okay, but I've timed it. One time was 5 minutes 21 seconds. Another one, the other time that I actually timed it, it was a little bit under 6 minutes. It's like 5:58. Okay, but there's kind of a discrepancy between globe some globe believers that I've talked to, and and my numbers, and then the actual numbers that they'll present you on one of those sites. It'll tell you how long you can see it for,
Mm-hmm.
and the numbers are closer to 4 or 5 minutes. The least amount of time I saw was like 1 minute. Just going on a quick list. Okay, just the quick, just the basic list that they showed for that day or whatever. It was between 5 minutes and 1 minute. But I've talked to several globe believers. One of them was Australian. One of them was American. Well, two of them were American, and one of them said he can see it for 6 minutes in Texas,
Mm-hmm.
and then the guy that was in California said that he can see it for only seconds. He says it goes by in seconds. It crosses the whole sky in seconds. And then
Okay.
the other guy from Australia said that it goes by in seconds too. Okay.
Can I? There's a pretty famous saying. I don't know if you've heard of it, but the plural of story is an evidence. So people get things wrong all the time, and
Yeah,
one person saying it's like, just because someone believes that the Earth's a globe, it doesn't mean that they you can depend on them to have an accurate account of everything. So if we're going to start
right,
holding,
right.
you know what I mean? Like there's a lot of stupid
But
things that get said by a lot of people. So I think it's really
what I'm saying is, to be able to see it from horizon to horizon takes 5 minutes, 6 minutes.
mhm.
Um, Going 17,000 miles an hour, it just doesn't seem like it's going that fast to me. Because a normal commercial airplane takes around the same. I mean, it's takes around the same amount of time for a regular plane to go by than it does this ISS.
Right. So are you saying that the ISS is at the same height as an aeroplane? Or is it
Well, I don't
traveling
know
a lot
that.
faster than an aeroplane, but it's higher up?
Well, it's not. It's not traveling faster, in my opinion. It's
If,
traveling around the same speed.
okay, then it would have to be at relatively the same distance. Otherwise, the speed would appear different because of the distance.
Well, I guess I don't know how you would be able to tell. Because
Yeah,
I
you know what?
mean,
I mean, yeah. Look, I'm not
if
qualified
it
to do that kind of
if it
stuff.
goes if it goes by in the same amount of time that a plane does, you know, it I would just expect it to be moving a lot faster. That's all.
Okay,
I
so
guess,
yeah, but yeah, okay, no, that's fine. That's fine. Yeah, that's fine. Um, I didn't even get to ask all my questions, but you've covered all of them, which is pretty cool. Um, I mean, once you get into gravity, I guess you talk about a lot of other stuff. But
So when are we gonna get it? When are we gonna get to the part where you tell me what your solid proofs of the globe are?
well, here's the funny thing. Look, people ask for proof of a lot of things, and that shows a fairly harsh misunderstanding of science where you don't go out to prove anything. That if something isn't falsified ever, or that you can accept that that is reality. Does that make sense? I fucked that up because I'm tired and hungry, but I'm not going out there to try and prove anything. What I try to do is to falsify things.
Oh,
And if
okay.
something gets falsified, then that is not true. Do you understand what I'm saying?
What?
So you should be trying to prove things false, not prove things
Okay,
true.
okay, it's the wrong terminology. Um, what indicates to you? What makes you uh, confident that the Earth is a sphere?
What makes me confident in the Earth's sphere? That's a better question. Um, I think to be honest, up until about 2 years ago, I hadn't really put much thought into it. Probably not even maybe 18 months ago. And I watched a video by, I can't even remember who it was, but it was ridiculous. There's no offense. Yeah, anyway. And it got me thinking. So I started looking into things. And obviously watching ships go over the horizon, that's something that you said. I've seen that. I've seen it with magnification. And I've also seen that it doesn't matter how much more you zoom in, no more of the ship comes back over the horizon. You only zoom in what is available. So that's a pretty good indicator. But the best thing that I found is that when you look into the sky and you start looking at other planets, they're all spheres. Why would Earth be any different?
Well, the first thing, um, the first thing
What would
you
be a better
said.
question? Would have been, how do I like? What's some things that I've falsified, or that I think is false?
Well,
I
okay.
think that's a better question.
The thing is the ships over the horizon thing.
Yeah.
You have to take into account when that supposed proof was put into
No,
was
you don't really.
well, but you do, because when they decided that ships were going over the horizon,
Yep.
they didn't have telescopes, they didn't
That
have
doesn't.
optics.
Yeah, but that doesn't matter. We do now. So that I've heard this point being argued before, and I think it's ridiculous because what they thought was happening, now that we can prove that it's happening, is still happening. It doesn't matter how they proved it,
Well, that,
or how they thought it was happening. But if
so
I
do you
if I went down to the beach right now, in the daytime, sorry, it's nighttime here, but if I went down and I took a telescope and I had a bunch of lenses, ranging from 30 times zoom right up to 300 times zoom, how much zoom do I need to bring a ship back over the horizon? You should be able to calculate that if that were the case, but
well
it's not the
the
case.
angular resolution, and there's a lot of uh, different variables
There is,
that
that's
has
right.
that are you have to take into account. And there's a really good channel called it's called Life is Short. Have you ever heard of that one?
I have not. Let me just write that down.
Life is Short, yeah. And or you could even go to my channel, Fight the Deception, and you can. There's a. I know this. It's labeled wrong. It's. I have it labeled as angular resolution. But I think there's like 6 videos. Um, so it's not like you're not gonna get through it in one
Yeah, yeah.
sitting. But the the guy that made the video, he mathematically and experimentally shows that objects do disappear bottom first on on flat surfaces.
Okay.
And he's got
At what rate?
he it lists all the rates, and I mean it's got a lot of math, but the good thing is this the guy, he explains it in both models. He explains how it works on both models, and he's mathematically calculated it down to within, I think, 20 or 30 miles of the accepted globe circumference. Okay, so um, and he gives you, the different point of views of from a ball to a, and he doesn't use the 8 inches per mile squared. He's using the radians and the arc distance or the
Mhm.
okay, so but yeah, if you get a chance, check that out because he breaks it down pretty good. There's, like I said, there's 6 videos, um, but he shows you, he walks you through it.
Yeah, right. Right. Do you know what the angular? Actually, I'll just look it up. The angular resolution of the human eye. Because if I took my um, reflector telescope down to the beach, that would compensate for some of the angular resolution problems.
Yeah,
I believe.
but on a flat surface,
Oh,
on a flat surface, not only is there, refraction and miraging taking place even over water, but as an object gets farther and farther away, yeah, it shrinks, you know, it the whole object shrinks, but the bottom does disappear before, you know, before the top of the object disappears. Yeah, on a flat surface too. It's just the angle, you know, like the higher up you are, the more surface area you can see on a flat surface.
yeah, and
Okay,
on
so
and on a sphere.
well, technically, the higher you go on a sphere, the more you're going to be looking into space. The more you're going to be,
Do
because the horizon should drop. You know,
you know? Do you know
like
in
this.
degrees? Because you're talking about angular resolution. Do you know what the degree per? Do you know how many degrees per kilometer or per mile of drop you
It's
would see
uh,
in degrees?
uh, per mile. I think
Oh well,
it's
it's
I
per.
think it's like 60 miles or 70 miles per
Yeah, it's 1 degree.
uh,
That's right.
1 degree, right?
Yeah. Okay. So have you ever tried to actually pick up 1 degree of difference away from you with your eyes?
No, no, I understand that. I
Okay. So
understand that.
that's it's just it's a bit of a disingenuous.
Well, I guess once it's not, it wouldn't be noticeable until you got really high up there, I guess. But
That's exactly that. Exactly. Yeah. 100%. We agree.
but um but on a flat surface, the higher you go, the more um the more surface area you can see in front of you. Okay, if you go lower to the ground, your surface area that you can see diminishes. The angle makes it, it makes it converge faster than higher up, I guess. And because your vision converges into the
Okay. Well, here's the thing.
apparent horizon, right?
Okay. So why, if the Earth is a plane, it is flat. Okay. And you are an observer. Let's just say that you're standing at 6 feet high. That's your eye level.
Mhm.
Okay. And you're looking parallel with the Earth. Why does the horizon? Well, parallels don't intersect. Parallel lines will not intersect. So you should theoretically be able to see
Not
forever,
not
even through atmospheric. So what you would see is like a blur, basically, because it would be just atmospheric conditions that you'd be seeing. There wouldn't be a horizon. That's and
well.
if you give, I haven't got time now, but I can. We can have another chat, and I'll draw out on Google SketchUp. I'll draw something out for you, and I'll demonstrate what I'm
Well,
saying.
I guess I look at it kind of like looking down a long hallway.
Yeah,
Um,
but if
if you look down a long hallway, um, and like, I don't know if you probably You guys do you guys have casinos there? Like big hotel
Nothing
casinos?
like what you have over there.
No. Well, like in Vegas, for example, if you go into a hallway, the hallways are really long, and everything. Even though I understand and I agree that parallel lines don't converge in reality,
Yeah, they appear to
from our
converge.
from our perspective, they do. From our,
That's
the way
fine,
we,
but they don't
and
intersect.
so
That's the point. So
okay.
converging lines. What do you see at the end of the hallway? Do you see a defined, like a black and white? Say if the carpet's black and the wall's white, do you see a defined line between the black and white at the end of that hallway, or do you just see something that you can't resolve with your eye?
I just posted a picture inside the messenger.
Yep. Yeah.
Um,
Yeah. I mean,
and so
that's
basically, you can't decipher that those lights don't actually meet the road visually.
um,
You know that they don't because they're all the same height and they're all,
I
but once
think
they get to a certain distance away from you, they do appear to converge at the apparent horizon. Um,
yeah, all horizons are
you know,
apparent.
even
Um,
even on a flat surface is what
uh,
I'm saying.
yeah, I'm not sure that that road's flat, and I'm sure that you're not sure that that road's flat as well. Um,
Oh, wow.
yeah, no, like
So,
this is where you get into
so
trouble because you need to
okay,
be.
here's another one. I just sent another one, and that one's kind of I would rather not have shared that one, but because it's kind of a meme. But here's the same thing. Here's
Okay,
another one.
okay.
Um,
No, I can see what you're saying, but
basically,
if you look down the end of that hole, if you look down the end of that row of lights, okay, what can you see? What you would call a horizon at the end of that?
um, what do you mean?
Is there a clearly
Can I?
defined? Is there a clearly defined point? See how all the lights just meld together. Let me present this. Actually, that one too because it's a. You know what?
I
I'm
sent
not
the, I
gonna
sent this I sent the same picture, but it's just a screenshot. Uh, it's
without the
just
writing.
yeah. And here's I'm gonna send another picture about the from a flat surface as opposed to a round surface. And I
Okay,
actually got this off of the Popular Science website, but I've modified it to be more less to be more honest rather than what they had when they had it. They had the person on the flat Earth standing. The person up elevated
mm-hmm.
could only see to the tree. See, there's lines. There's like dark straight lines
Can
pointing
I?
from the eyeball to the tree, and then the guy on the bottom, he's his eyes looking straight to the tree.
Can you
Okay,
just
well
go
they
back? Oh, sorry.
go ahead.
Um, if can you just go back to that meme that you sent me for a second, or the screenshot without the meme on it? Now, just
Yeah,
if you follow those lights, can you? There becomes a point where you can't distinguish one light from another, and everything is just a blurry mess down there because
right,
that's what happens when things converge, and
right.
that's not what we experience with the horizon. What we experience with the horizon is a clearly defined line to the horizon. I'm talking about looking out at the beach over the ocean. You see sky, ocean, line. But what you see here is everything blurs together because there's too much. It's too small and there's too much information for your eyes to resolve it. And that's where the parallel lines, if they were intersecting, if the lines were intersecting like they do, then we would see a horizon. But this photo that you've sent me, I think, proves my point better than it proves your point.
Um, I don't see that. I mean, I
There's
guess
no horizon. Like if you can draw a line in, right, and then we can zoom in, it's just indistinguishable. There's nothing down there that is distinguishable.
yeah, I know that's what happens on a flat surface. So
Yeah, exactly. But if that was a curve, then that wouldn't happen. You would have the geometric shape would stop you from seeing the land, but you could still see beyond that because the land would curve away from you and you would see a clearly defined line. And that's what I'm saying. On a flat surface, you'd see this blurry blur all around. But on a curved sphere, that's not what you would see, and that's not what we see. And that's the point I'm getting at.
Well, I guess that's we're gonna have to agree to disagree on that one because I mean that's what I see happening. I mean you're questioning that particular picture, but I've been on roads just like that, and the road is not a sphere, where
yeah,
like in Oklahoma is considered flat as a pancake, they say. It's been measured. It's been measured to be flat as a pancake. But the street lights, they do exactly that. You can't decipher the actual horizon from the lines do converge to your perspective.
That's right, and that's not a horizon. So that's what I'm saying. It's convergence, so it's different. I've just opened up that other. I think it's a meme that you've sent me. Yeah. What does it say? On a flat surface, higher elevation allows you to see over obstructions. Okay. So this is, I'm presenting it so that everyone can see, but I'm not sure what you're trying to get at here because this is either extremely dishonest or a joke.
Well, okay, so you have to see the original one to make a determination on what's
okay. Well, here's the thing. Just with this one that you've sent me. So just with the thing that you've sent me. So either that tree is thousands. It's really far away, and on a flat surface, you're saying that you can see extremely far, or the curve on the round side has been over exaggerated because that it's just it is dishonest. It really is. It's not a comparison at all. If you find me, I'm only looking at what you've sent me. So unfortunately, that's all I have to work off.
Like I said, I modified that. It comes from Popular Science.
So what we agreed on was that on a round Earth, you would see 1 degree away from you every 69 miles. So if you counted the amount of degrees of curve on that bottom photo, and then calculated that into the amount of miles it would be, yeah, that's where the dishonesty is. Because either you're saying on a flat surface you can see hundreds of miles, no matter where you are, or you're saying, or you've exacerbated the curve on the round side.
Well, no, basically what that image shows is somebody on a flat surface. The higher up you are, the more you can see over obstructions that are at compared to the guy at ground level.
Okay, so if you got a protractor and put it on the round side, what angle would the two guys be angling away from the tree? Roughly, do you think?
Away from the tree?
Yeah. So see the sharp angle that they're on.
The guys on the flat.
On the round one.
Oh, okay. The angles. I'm not looking at it right now. I can't really say the angles for sure right offhand. Probably. Well, the thing is they're standing on the earth and they're looking straight ahead, right?
Well, no, they're not. They're looking at the sky.
Well, but they're still 90 degrees to the surface of the earth, right?
Yeah, and they're absolutely giant because the earth is huge, and that amount of curve is just so over exaggerated. It's not really serving a purpose. The image isn't serving a purpose. I was just trying to figure out if you were being serious when you sent it to me.
Hold on a second. I got a link. I gotta give you a link to the to the original one, and you can or I'll take a screenshot maybe and
Yeah,
leave it in the
that's
chat.
fine. That's fine. So I've got about 15 minutes left, and I'm gonna have to jump off. So
Okay. Here, hold on. I got it here. Um, yeah, the popular science 10 ways to. It's called 10 ways to prove that the Earth isn't flat. And okay, so just take a picture of this one real quick. Oops. What the, okay, and then I'll take a picture of the round one. And what I want you to notice on this popular science in these images that I'm putting in the messenger is that I want you to look at the angles of the people's heads, the
yes,
angles that they're pointing, and also I'd like you to notice the people on the flat Earth for some odd reason, like the guy that's elevated. For some
mm-hmm.
reason, they have his head tilted down to only look at the tree, right? And in reality, we know that if he was looking straight ahead, or even looking a little bit above the tree, or you're going to see farther than the tree, right? You agree with that?
Yes,
Okay.
yes,
And
I believe so.
the people on the flat Earth, for some reason, have only a line of vision, a point, just a straight line that they can see. But then you go down to the globe people, and they have a big old wedge, you know, a big field of view for some reason, and they have those people's heads. Um, if they were standing straight up and looking straight ahead, they would be looking into space already. But instead, they have their heads tilted down to look at, towards the horizon or whatever.
Okay, so
But
this
the
is
angles of their heads are tilted down. They're not looking straight ahead like the people on the flat Earth are. You know what I mean?
okay. So uh, so what's happened? It's what you want to do. You want them to draw the same angle on the flat Earth. Is that your problem?
Well, if you go back to my
Okay,
the meme
because
I
I looked
sent
at
you.
your meme, and on the flat side, if the guy on the bottom, his angle is not it's not equal. His viewing angle is not equal, um, and you can tell that just by measuring the distance from the line to the bottom of the cone and to the top of the cone. Do you understand what I'm
Right.
saying?
Okay. Yeah. The angle. Yeah. The guy on the
Yes,
bottom.
and
That
even the
that
guy on the
that's
top. If you centralize your cone to the center to that line, it's it's just as honest as it was in the other one. But the dishonesty is in the actual picture. The curve is over exaggerated, and that's not a very good example. It's a very simplified example in a cartoon, which is
right.
just being used to
Right.
demonstrate a simple point. So I think you've read too much into it.
Well, that was one of the 10 proofs that the Earth is a globe.
Well,
So
because it's simplified for everyone. It's hyperbole. It's just an easy to understand representation, and
but
I think it's
it's not an honest one,
it's
right? Because
no,
the
it's not
guy
honest because the curvature is way too exaggerated. Because the problem is, if they did it realistically, guess what? The ground would look flat on the curve on the globe side as well, because that's how big the Earth is. So they have to exaggerate the curve to make their point. That's the point. That's what
but
hyperbole is.
but don't you think giving the people on the flat Earth just a straight line of vision as opposed to what the people on the globe's vision, don't you think it's like
I
never
understand what
mind.
you're saying. Okay.
It wasn't some a point that I was really trying to make too much. It was just kind of a.
Yeah, I think it's an odd point to make, but I'm fine
Well,
to use it if you want. But yeah, I'm just going back to look at your photo that you have, and you've done exactly the same thing on the round side, and you've drawn in their angles with arrows, which are not true, like not representing. They're basically stick figures with balls on their heads. So you can put that arrow wherever you want, and you've chosen to put it off looking into the sky to try and prove your point. And
well,
so
no,
it's a
I
little
mean,
it's kind of a little
I
bit
think.
hypocritical to say that it's wrong of them to do it, but when I do it, it just I don't know. It seems a
No,
little bit like a straw man kind of argument, and if you get where I'm
well, in my opinion, if you were to give the two people on the globe a straight point of vision, 90 degrees, if they're standing straight up and they're looking straight ahead,
yeah.
um, yeah, the angles are still wrong.
Okay, so if
Um,
you give the guy on the top an angle straight out,
mm,
he's not looking at the tree either. Then you've got two parallel lines from the bottom observer and the top observer. So I'm not
no, no,
exactly sure on your point.
I understand that.
Yeah.
Basically, it was just the. I agree that the angles are still off on all of them, but
Yes.
I just think that the what they're trying to present here is is vastly more uh, deceptive because obviously the person on the flat earth that's elevated is going to be able to see past the tree. He's not just going to tilt his head down to see
Yeah.
only the tree.
No, I understand that, but what would be the point in that representation? What they're trying to say, what they're trying to get across, is that they can both see the tree. They're not trying to say that one can see the tree and one can see far beyond that. They're just you have to take context into account.
No, it says right there, point of view on a flat earth. How far can you see from a height? On a flat earth, elevation doesn't make a difference.
It doesn't.
you know.
It
Well,
doesn't. Once you
yeah,
get no, listen.
you can still see farther.
once you get above atmospheric conditions on a flat Earth, it would not make a difference if you were 10 feet higher or not. Like, why would that make a difference? If you could zoom in, if you could magnify things, then you could see equally as far, 20 feet apart, as long as you were in an atmospherically stable condition. Whereas on a globe, on a sphere, that wouldn't happen.
If the person that's the level with the tree on the flat earth, the
Yes.
person that's on the same level with the tree, the person that's elevated is going to be able to see that much more, that much more, however much higher they are, they're going to be able to see that much farther because obstacles,
Yes, no,
objects that are,
that's why I said you have to be off the ground. So you get away from atmospheric conditions. You get away from any obstacles on the ground. If I could float at 100 feet and you could float at 150 feet on a flat Earth, there's no reason why you and I could see. There's no reason that you could see further than I could. There's no reason at all because
yeah,
you know what you'd be doing is creating two parallel lines. So on a sphere, if the same thing happened, then you can only see as far as the geometry of the shape would let you. Anything that goes beyond that curve, you wouldn't see, and that's. I'm having trouble understanding here what you're trying to say
um,
because there's
the person that's 150 feet in the air is going to be able to see farther
why,
because they can see more surface area
but the surface area wasn't hidden
of
at 100 feet. It was exactly the same amount of surface area because the Earth is flat. Remember?
flat plains. The higher you go, the more surface area you can see.
That,
It's not curvature. It's just the angular, the angle that you're looking at it from. The atmospheric factors do play a part, but that's not even what I'm talking about. I'm talking about just the angles involved. Um, you know, it's like if you go out to a football field and you lay down and you put your face on the ground and you're looking straight ahead,
Yep.
and you have somebody walk away from you,
Yep.
they eventually will start to disappear from the bottom up. And if you stand up or if you sit and your elevation changes, now they it will take a lot longer for them to start disappearing from the bottom up, but they eventually still will. You should check out that
Have you
channel.
been to a football field? Just like
Yeah, you're gonna bring up the crown that's only in the middle of the field, though, right?
well, where yeah, look, what I did was I took an example and I made it big, right? So only big objects would you and I would be able to see if we were 50 feet apart, 100 feet in the air. So I'm asking you why, because you're 50 feet higher, the angle that you would have to look at would be more extreme than the angle that I would have to look at to see the same object, unless we were. It's just not making any sense to me. Can you send me another meme so I can that better explains it? Because the argument that the meme that you sent to support your argument doesn't support your argument the way that you think it does.
I never said that meme support, and I was never trying to.
Well, that's what you sent me as an introduction to this argument that you had. Like that's why I'm so confused, because
No, it was something that we talked about kind of briefly earlier, but no, that wasn't any kind of proof of anything. If you actually want, I know you're short on time now, so
I am, but I'm happy to
I will.
have you back on another point when you're better prepared
Yeah.
with a computer or whatever, and you can present your sort of your own evidence.
Well,
like, you know what I mean? So you don't have to rely on sending stuff through Messenger and etc.
yeah, well, let's see.
I just don't see how.
Okay, I'm gonna leave the link to this playlist.
Yeah.
And you should check it out whenever you have time.
Yeah, no worries.
It's really really informative, and I think it's explained in this video series a lot better than what I can do justice right now.
Okay, so what is it about?
It's already 4:37 here, so it's
Hang on, someone's asked a question in the live chat, and they want me to ask you.
Sure.
So they've asked, why can we observe unobstructed ocean sunsets, full angular size sun setting below the ocean horizon while not getting smaller and disappearing into a dot?
Well, the sun does get smaller. It doesn't necessarily disappear into a dot every time. It does sometimes.
The moon, the sun gets smaller, did you say?
Yeah, the sun
How have you
gets
determined
smaller,
that?
By I'll leave another link to another video that I made. I've went through Wolfie's videos. I've went through Red's Rhetoric's.
Okay.
And
even
even in their own videos, the sizes of the sun changes.
How much?
Not as much as, I wouldn't say.
It's within a tolerance, is what I'm getting at. It's a very minimal. It's a minimal amount.
I wouldn't say more than like 10% or 20%.
I would be surprised if it was anywhere close to 10%. To be honest with you, I would be extreme. I'd be really surprised.
Well, you can. I'll leave a link. I'll leave a link to my video, and you can check that out too.
How did you? So you're talking about, I know Red's Rhetoric's footage that you're talking about. How did you measure the angular size of the sun to determine that it was shrinking, getting smaller? Sorry.
Well, I haven't actually done it myself, but I think that the footage on the video speaks for itself. I mean,
Okay. So are you talking about someone breaking down someone else's footage, or are you talking about someone's raw footage?
well, basically, it's a compilation of different, you know, uh, observations by various people. But it you can check it out. I mean, it's
Yeah, sure. I'll have a look. But my point is, when you view the sun without a solar filter,
no, these have solar filters. These have filters.
they have filters.
Yeah.
Okay.
And like I said, even Wolfie's videos and Red's rhetoric too, man, uh, show a change in the size, even on their videos.
But
They don't
I asked you how you
admit to it.
determine that. Like, are you
Well,
just looking at it and
there's
eyeballing it, or are you measuring the
no,
pixels, or have you got a ruler over the top of it? Like,
there's like I said, it's a compilation. There's a variety of there's a variety. Some of them, the first few are just are kind of crude, but as the video goes on, the quality of the observations gets better and better and better, basically.
right.
And it's done with a camera that, some of them are done with cameras that they don't zoom in. Like the Coronado.
Mhm.
It's done with a Coronado solar filter that that um, that you can't make it get any bigger or smaller. It's set. The focal length is set uh, to a certain. It can't magnify it anymore. You understand?
I understand what you're saying. So,
Uh,
so I just want to clear something up. What is your tolerance? Like, what would be the workable tolerance you think when you're photographing the sun every half an hour throughout the day with a solar filter? What would be the acceptable tolerance on the size of the image and everything remaining the same
um,
throughout?
like I said, it's really hard to say because of the atmosphere. The
Yes.
atmosphere
Okay.
can
That's
magnify it. It
yeah.
can,
That's fine, man. But
obscure it. I can't.
um,
I don't really like speculating too much on how much it should change because I
no,
really
I
don't
get that.
know how far away it is. Or even really what it is. You know.
That's a discussion for another day, and I know someone who's qualified to tell you about it. But I have another question that's just popped up.
Well, I mean, I know all the official what we're told as the official distance and all that. But to be honest, to be honest, I have went through so many hours of footage and so many hours of evidence that tells me that a lot of what they're telling us is not true.
Um,
You said you'd never seen a funny thing happen on the way to the moon, right?
yeah. In all fairness, I'm not looking for something funny to happen on the way to the moon as well. So what have you
Well,
found?
that's the that's the footage that I think
Are you
shows
talking
that.
about when they say something about? Are you talking about the faked image footage? Because I don't think that that's really worth even talking about, to be honest. If that's what you're talking about.
Well, you're talking about
The one where they discuss
they're
setting up an image, and everyone thinks that because they had to do preparation to set up to take it, one of the greatest images ever taken, that somehow proves that it was all fake. Is that the one that you're talking about, or am I
um,
jumping the
mm,
gun here?
I think you might. I don't. I think you might be jumping the gun, but this is footage of them supposedly 130,000 miles from the
Mm-hmm.
Earth. They're looking back towards the Earth
Yep, from before.
um, from the from the Apollo
Yep,
11,
which is the anniversary today.
and they're moving the transparency that they have over the window. Okay, they have a thing that they put over one of the windows that has a round shape cut out of it. Okay, it's kind of like a crescent almost
Yes,
shape,
I understand what that is for. Yes.
and they have the camera way far away from the window, and they're taking a picture. They're taking a video of supposedly the Earth through this little hole, and they have all the lights shut out,
Mhm.
and they're rotating the Earth around to try to make it look more legitimate, more believable, I guess.
Um,
For about an hour, they're doing that.
okay.
And
What's 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 wrong with
they're
that?
talking about well, because it's not the Earth that they're look.
Uh,
It's not
what do you mean it's not the
because
Earth?
okay. I'll explain it again.
No, just link me the video, and I'll
Uh,
I think it's the same one. Like I think I've watched a few, but one of the ones that sticks out is a woman narrating it, and she's pointing out all the things that are supposedly proof,
yeah,
and none of
that's
them. Is that the one?
yeah, that's the one
Yeah, great.
where and have you seen the it's kind of related to it. It's called Astronauts Gone Wild. Have you seen that?
I don't believe so, but let me just take a note. Astronauts gone wild. It's not the falling over astronauts, is it?
No.
Good, because I'm sick of
No,
looking at that.
this is where the guy who actually was making the documentary in the first place, he requested some footage from NASA,
Mm-hmm.
okay, for his documentary, and NASA sent him some reels of film um, to use in his documentary, and one of the reels ended up being these outtakes, these they were never used, they were never broadcast or anything. These outtakes of Apollo 11 astronauts trying to, you know, fake this fake this footage of the Earth in low Earth orbit. Basically, they're in low Earth orbit. And they put a thing over the window, and the thing has
Yes.
a hole
Yes.
cut out. Okay,
So
I
that's
understand that.
okay. So that's setting up the
And then
frame. There's
and
nothing there.
then and then he interviews Buzz Aldrin, and he interviews Alan Bean and several other astronauts. Okay,
Mm-hmm.
and the interview, um, to me, I mean, I could smell bullshit a mile away. Okay, and and the things that Buzz Aldrin is saying are not something that are they're just really suspect to me, especially considering the footage that he gets confronted with and his attitude about wanting to be interviewed while watching this footage, um, and just the things he says. He at one point he says, "What an ego you must have to be the one who uncovers all this stuff." And another point he says, "We were just guys going on a flight. Why don't you talk to the people? Why don't you talk to the administrators at NASA?" After he's confronted with this, this footage, and I just don't see the guy, the guy who made the documentary,
Mm-hmm.
fabricating fabricating a big old video and then going and confronting and paying these guys. I mean, he paid them like $5,000 just to interview him,
Right. To
type of
do
thing, you
to
know?
make a documentary, did you say?
Yeah, he was making a documentary, yeah.
Did
But
that documentary go to film, or is that did that not happen?
say that again.
Did that documentary ever make it to film, or did it ever get to the public?
Yeah,
Was it
it's the one.
was it monetized at all, or not at all?
It's free on YouTube. I mean, I'm sure the guy probably was trying to make money on it
That's
originally.
exactly right. So motive is a pretty important thing when it comes to stuff like that. And saying that I can't see why he would fabricate a lie. I mean,
Well,
isn't
not
that the
only
reason
that,
that you
but
said that NASA lies for money, and then you
don't
just turn around and say this guy because he agrees with me, obviously he can't lie.
don't.
That's a bit of a confirmation bias.
I didn't agree with the guy at the time,
Well,
so
that
that's
doesn't
a
matter. That doesn't
invalid.
make that doesn't matter. You can still have a confirmation bias now with your opinions. It's
Well, but what I'm saying is, you know, honestly, I haven't ever seen anyone refute the evidence. I mean, I don't see how the guy would have would have fabricated these reels of film from these, old.
exactly. So how did so if oh man,
It
no
was
one
NASA
fabricated.
footage.
No.
It was
Yeah, it was NASA's footage of Earth. Real. They took a photo of Earth from the distance they said they did. They had to set up the frame so that it would be a nice photo of Earth because why else do it? Why take a shitty photo of Earth?
Well, it was a shitty photo.
It's a great
They
photo.
had they had not the one I'm talking about. They had clouds, one single ribbon of clouds that extended all the way across the whole Earth,
Oh my
type of
god.
shit.
No,
Yeah, I
this
mean
thing that you just sent me. Oh yeah, okay, don't worry.
that's
Yeah, that's all right.
that's the original one. The one here. I'll link the other one too.
Let me just ask you this question off the live chat because someone wants to know the answer to this question.
If you go to 22 minutes and 28 seconds of that video I just posted,
The moon video, yes.
you can see
28 minutes and 26 seconds.
I think 28, 26, yeah.
1 second, let me get it there and I'll present that. What about it that just says Apollo moon missions?
Maybe I was. Let me see it.
Expeditions to the moon. This is on the video that's titled "A Funny Thing Happened on the Way to the Moon." Is that
Yeah,
what you
they showed the image, but they didn't
showed the video?
talk about it right there. Hold on a second. Okay, instead go to 32:40 or 30. Just go to 32 minutes,
32
and you
minutes.
can see that there's ribbons of clouds.
No, I'm just getting to
You
30.
can see there's ribbons of clouds that are, kind of extend the whole entire length of the Earth.
Hold on a
Also,
second.
you can see how the astronauts, when they're running around on the moon.
Are you talking about at 32 minutes and 9 seconds? Is that what you're talking about?
Yeah, pretty
That
much.
photograph of our lovely Earth.
No,
Okay.
it's a video. Here, it's
Are
gonna
you,
play it
are
now.
you
It's
sure
gonna
that
play it now.
we're on the same video?
A funny thing happened on the way to the moon. Yeah. Yes.
Okay. It's just lots of fast flashing photographs.
It's not on a video of the Earth right now.
Here you go. You got your timestamp wrong. It was 32:20. Do I need to hear this? Should I turn the volume up?
Yeah, you can listen to it.
We'll just stay quiet a little bit and we'll have a listen.
You can see them rotating the cutout.
Sorry. What I just saw is them
Hold on.
rotating the camera.
They're rotating the camera.
Why did you laugh at that? Explain to me why that's not possible. Explain to me why you couldn't rotate the camera.
Because you can hear the astronaut say that he's turning the world upside down. Hold on. He says, hold on to your something, Houston. We're turning you upside down.
Yeah, because do you think that maybe he knew that when he turned the camera, it would change the perspective of the camera so that the Earth turned? Do you think, like, is that just as plausible as that they were faking the whole thing, or?
No, because if you wait a minute, if you wait a second, it will show you. It'll just watch it. Just watch for a second.
Okay, just think on that for a second. Okay, hang on a second.
Just wait. You're about to miss it.
I'm at 32 minutes and 57 seconds. Have I missed it already?
Yeah, I think you have. I'm at 32:34 right now.
Okay. So do you see how much the Earth moves in that frame, in that video at full speed? You see how it moves around a lot?
Yeah.
Have you ever tried to photograph something that's really far away? And it's difficult to keep it in frame. Now, if that was a cardboard cutout and they were just turning it, don't you think it would be really easy for them to keep that in the frame of the camera, which is a pretty big camera? I mean, are you able to go frame by frame on the video that you have?
Not really.
It's fine. We can do it another time.
The part that I'm talking about, it still hasn't happened yet, though. It's I'm at 35:28 right now, but you can see objects come in between the supposed Earth and the camera.
You were going to say.
Huh?
I thought that's what you were going to say. So, did at any point did they say that the camera is right up against the glass? Did they?
Yes. Yes. He's saying it right now.
What's the timestamp?
35:40. Say 35:48, maybe.
Okay.
He says we have the camera pushed all the way up against the window.
Just for a second.
And huh?
Okay, I didn't hear them. I listened from where you gave me right up to 36 minutes and 9 seconds, and not once did they mention that the camera was hard up against the glass.
He does. Hold on a second. Let me find it.
She says that they said
That's exactly what he says. He says camera's all the way up against the window, and he says that they have all the lights turned out inside of the.
Okay.
Inside of the.
I didn't hear. Maybe I didn't hear it because you were talking. So just give me a minute. I'm going to play it through one more time. And
it's somewhere in there. I mean, let me try to find it.
Starting at 34 minutes and 30 seconds. So let's listen. Just. Oh God, I wish this woman would shut up.
Mainly the part that I'm talking about happens after they get done talking, and you can see they pull the transparency off the window, and you can see the whole Earth, the whole big blue Earth in the window after they pull the transparency off.
Okay,
But
hold on a second.
it's like they almost thought that the camera was not running anymore, but it
Just
was, and they never used any of this footage, you know, they never played any of this footage back.
thank.
You know, uh, it was never broadcast
Okay, I'm listening now.
because they took a lot of out. Oh, sorry. It's at 3540.
I
Is
just,
where
I just
it
listened
talks
to it.
about that.
Okay, but his words aren't. I've put the camera directly up against the window. Are they? That's not the words that he used.
It says we shut out the sun coming in from the other windows into the spacecraft so that. Well, okay.
Yeah, so there's obviously air, there's space in between the camera and the window that something could pass through. I'm having a hard time. I've seen this video before, and I don't know what you're trying to point at here. And so many people point at the same thing. And
He does. I know he says. I know for sure he says that the camera all the way up against the window. That might not have been the exact part.
I just okay. Well, I don't really have much more time to spend searching through videos. But
Yeah.
I don't. Yeah.
I mean, I wasn't planning on presenting. I thought we were just, you know, having a chat, but
No, that's fine. It's just
I can
I've
have
seen
I
that
can
video.
have the I can have the exact timestamps to look at it. I'm just going through these
Well, how about this?
videos
How about this?
on the fly, kind of.
Not this weekend coming, the next weekend. Let's reschedule for then. I'm going to give you that long to sort of get everything together, and hopefully your laptop's working. You can be a little bit more prepared. And
Okay, here it is.
can
It's
show
at
me.
38:15. He's about to say that he has the camera pushed all the way up to the window and whatever.
Hang
38:15.
on a second. Just try and stay quiet because your mic's quite loud over the video. So
Okay.
okay, I'll have a listen. Okay. Now,
Did he say that or not?
no, he definitely did not say that. You know what he did say though?
What?
He did not say the camera is up against the window. He said there's only one camera that has a view of the Earth, only one window that has a view of the Earth, and it's filled up by the camera.
Okay.
So those are two.
Okay, I misquoted him a little bit, but
No,
well, what do you take that to mean? You don't take that to mean the camera's up close to the window?
it's close to the window, but it's not on the window. There is.
He said it's taking up the whole window.
That's right. Have you seen a photo of how big all the gear was that they had? You know, and all.
The Hasselblad cameras weren't that big.
No, they weren't that big, but how big's the window?
I don't know how big the window is, but I know that you can see the Earth. You can see how big it gets afterwards.
Okay, here has this. Let me try this. If I was standing in front of a window in your house, and I put my arms out and spread my legs out, I would say that I'm taking up that whole window. Am I up against the window? Can nothing get in front of me? No. But I am taking up the whole window. So what he's saying is the camera is taking the space in front of the window. The only view of Earth is taken up by the camera because that camera is capturing Earth. I think this is a pretty weak thread to hang on to as an argument, in my opinion.
Okay, well, you didn't watch the whole.
I don't.
If you go to,
I don't have.
okay,
I don't have time to sit here and watch a 40-minute video that it explains the whole thing.
It's 39. If you go to 39:14, you can see the Earth is. It looks like the Earth is really far away, and then as it plays, you will be able to see the Earth, the huge Earth underneath there. It transforms, like, basically be a little bit past 39 or the time I just said. It's at about 39:41, and you can see the whole entire Earth underneath there.
39:41.
Yeah, and that'll be the last place you need to go to.
Are you sure? 39:41, because it's just a photo of an astronaut's face. I'm doing it.
39:41.
Yeah, that's where I'm at.
It's a picture of an astronaut.
Yeah.
Okay, but what's the blue in the window?
I don't know what blue in what window. Maybe because I'm doing it frame by frame. We've stopped on a different frame. Maybe that's what the problem is. No. Sorry, I'm not seeing what you're saying, man. I can see sunlight coming through a window. That was it. And it's back to a video of Earth. Yeah.
Okay, I'm gonna take a screenshot of it then.
Sure.
Since you can't see it, or you're not seeing it. There's the astronaut there, and he turns. Boom! There's a light that lights up, and it's blue. It's the blue Earth.
Right.
Underneath of him.
It's okay. Yep.
These screenshots didn't turn out good, but I mean, you said that was the sun coming in.
Well, that's what I could see. That's what I could see.
And the sun is blue.
Well, I'm not seeing any blue light coming through the window. So you send me your screenshot. I'm going to screen share my screen.
Yeah, so I sent 3 of them.
Yep, no worries. I've shared my screen. So
you have to realize that where they were just looking at was supposed to be the Earth from far away, right? Okay. And then it changes to, it shows you that the Earth is actually close by, and the reflection, that light is actually coming from the Earth, not from the sun.
Right. So where's the time? Do you have any timestamps on the video so you can determine the order of events? So wait, are you talking about this blue light coming through the window here?
Yeah, 39:41, I think it was.
Okay. It's not lined up to that. It's not lined up to that on my on my browser. That does not line up the way you said it is. Oh. But I can see what you're saying now. So you're saying that. So all you're doing here, right, is you're making an assertion without any evidence. Well,
how is it making an assertion when these videos are timestamped originally?
Okay, where's the? Can you get that time? Can you get those timestamps and put these into order?
It shows them. It shows them on the, when it goes to the blue screen. Okay, when it goes to the blue screen and it says Apollo 11, it says this film is not meant for public distribution or whatever. That's the way the original Apollo films looked. They have the little they tell you what day it is, what time it is. And see, when they took those pictures, those first ones, they were they couldn't have been walking on the moon X amount of hours later when they were just that close to the Earth.
How have you determined how far away from the Earth they are?
How have I determined how far away? Because
Yeah,
they
in
say
that photo.
that, from what they say, they're 130,000 miles out, or
okay, out from what? Out from where? Sorry, just so we can get
out from the Earth. They're 130,000 miles away from the Earth, supposedly.
Okay, so how much further do they have to go to get to the moon?
100,000 miles.
100,000 miles.
Right. 240,000 miles.
Yeah.
Give or take. So
what seems to be the problem here? And the other thing I do want to ask is, are you trying to tell me that they're not in space, or that they are in space? Because your argument is that we shouldn't be able to see that blue light because they're so far away from Earth in space. But in the same breath, you're also telling me that they're not in space. So it's a self-refuting argument.
Basically, what they've done is they put a cutout over the window. I already told you this several times, but they put a cutout over the window. They put a cutout over the window. You can see that the clouds extend. One ribbon of clouds extends over the whole entire Earth. You know, like from one end to the other, just one ribbon of clouds. Okay. That looks real to you? That looks like, I mean.
Oh my. Yes. To answer your question, that photo, I have absolutely no reason to doubt that photo is correct. That video is correct. Yeah.
Oh.
Okay, so can you tell me? Can you tell me? That's fine, but I just want to know, in your opinion, what would limit the size of the cloud? So why is that impossible? In other words, sorry.
Why is it impossible?
Yeah, why is it impossible for that cloud to stretch?
I think it's a lot more possible that those clouds are just taken from a little section of the Earth rather than the whole entire Earth. So you would see ribbons of clouds that extend all the way across if you were just taking a picture of a small area of the Earth, you know?
Yeah, but there's things there that you can measure. Like there's land masses under the clouds. You can see large land masses. Either the clouds are tiny, like either what you're saying is true and the clouds are absolutely tiny. Like
you don't really see land masses. You see little parts of land, but that could be, I mean, that could just
but saying that it could be something else doesn't mean that it is something else.
Yeah, I guess you're.
Yeah, I mean, look, if you showed me something that was irrefutable, I would not be refuting it. But what you're showing me, honestly, like, it's been shown enough times that I already said that I didn't want to get into this lady's video, which somehow has 2 million views. That's ridiculous, and it's been explained it's been debunked many times, many times, more times than you'd care to count.
Well, I haven't seen any. I haven't seen any debunks for it, but you know, it's that coupled with astronauts gone wild.
I don't have time to bring up any more videos.
Yeah, that's fine.
Yeah, it's almost time for me to head out of here. But I mean, you've got a lot of stuff that we had a little bit of trouble displaying it tonight, and obviously you weren't that prepared. So next time, with some more evidence, we can both be more prepared, because this is a pretty impromptu thing. I literally just got home from work and
I
just jumped on
was.
here. So. But that's fine, man. But my point is that at the start of this, we both agreed that evidence, actually finding truth, is the important part, and that what we would do is we would find things that were not refutable, and you said that you were interested in the truth, and when I show you that there's a far more likely scenario, or explain that, you just say, well, because it doesn't fit my narrative, then it has to be this. So what you do is you start gathering these little tiny things that all conform, and then you start putting it together. And that's how all conspiracy theories start. Well, it is. You can laugh all you like, but that's what happens, So.
Well, I guess I've just seen. I guess I've seen different, film.
You and I just looked at that footage, right, together. You and I, and
Yeah.
we saw two completely different things.
Yeah. Maybe you didn't watch it. I mean, I don't know. I don't know why you can't see the blue, or
Of course, I can see the blue, but I want to know. That's what I was asking you. That blue color. Firstly, neither you nor I can prove where that light is coming from. That blue color, that blue light. So, firstly, it's unfalsifiable. I could say that it's a flying pink unicorn that somehow makes blue light out of its ass when it flies, and there's no way that you can disprove that. And you can say that it's proof of the moon hoax, or whatever you want to say it is. It just doesn't really mean anything when you just say things like that. Like, it's just a throwaway statement. And saying, when you said that he said that it was directly up against the glass, he didn't say that at all.
Well, he says that the cameras take the whole entire window.
Yes, it's taking up the view of the window. That's right. That is what you would do if you were trying to take a photo with a large camera through a small hole. You would place it in front of it. So that camera is now taking up the space behind that window. Like, I understand. Like, what you're doing is you're taking the words and you're twisting them to fit what you want to hear. Like, that's not what was said. Look, it's pretty obvious.
You might not have heard it, but
it was on the screen. It's in writing what he says. It says that he says that the camera is taking up the window. He didn't say, I've put the camera up against the glass of the window. He said it's taking up the window. They're two completely different things. Yeah, look, someone just pointed out that that means the view of the camera is taking up the entire window. So
right. So how are objects getting in between the
easily?
Camera
like I said, let's go back to it. If I stood in front of your window in your lounge room, I don't know if you have a window, but let's just say you do, that goes, from 2 feet up on the ground and it goes 4 feet high. If I stood in front of that, 1 foot behind it, and put my arms and legs out and started doing star jumps, I would be taking up the view of that window. But you could still put your arms in front of me. Is that enough of a visual representation? If I had my face up against the glass, you wouldn't be able to put your finger between my face and the glass, but that is not what's happening.
Well, I guess we can agree to disagree on that. I mean,
I don't see how you can disagree with that. Are you saying that?
Well,
are you saying
because the Earth, because if you go back to that, if you get a chance and you go back to that, it shows the Earth really far away. They say that they're, I can't remember how far they say they are, but the Earth is really far away. And then as the camera moves, as they change their position, you see that astronaut, you see the window that was there, and it's all lit up blue because of the Earth. They're right above the Earth. In my opinion, that's what I see.
Yeah, I mean that's because I think, no offense, but I think that's just because that's what you want to see, and there's no way of you proving
Well,
that.
I, I saw this long before I was
Okay,
long before I didn't believe in NASA and all that.
okay, so
So
let me just ask a couple more questions, and then I think we're gonna have to get out of here. But that blue light coming through the window, what are you saying that it is? What is
the
creating that blue?
Earth,
The
the
Earth.
Earth.
Okay, so the Earth, so they're in space, they're above Earth, they're 100, they're in space, is what you're saying.
Yeah, I don't know how high they were, but
Okay, so they are in space. That's what I'm asking you. Is
they're not. They're not 130,000 miles from the Earth, though.
well, you can't prove that. Firstly, but secondly, it doesn't matter.
Yeah,
It doesn't matter. It doesn't matter.
it doesn't
Yeah,
matter. Well, how could they have walked on the moon if they were just right above the Earth?
we're talking
How
about a
could they have
still frame
walked?
from the video. We're not talking about them walking on the moon. You're saying that it's impossible for blue light to come through that window at that distance.
No. N- Well, that intensity at the what they had just showed of the Earth as being a little tiny, you know, small, small ball, and then it
Do
goes to
you know,
that, and you see the whole Earth under there.
what year was that footage taken?
1969,
1969. So what?
July the 19th or the 20th.
So can you? I think you and I can both agree that cameras have come a really long way
Sure.
since then. Right. So all the exposure settings and everything on those cameras, nowhere near as fine tuned. Well, they could have been. They were good cameras, but there's a lot of reasons why that light could appear to be blue. Okay, and a camera will pick up all of the available light it can and use it. Okay, that's my first point. My second point is that anything that you see is reflecting light, no matter how far away the moon is, the Earth is. If you're seeing it, it is reflecting light. Okay, and you're going to see it to be blue.
Okay.
That's just how it works. If it doesn't reflect light, you don't see it. It's as simple as that.
All right. Well, the camera settings didn't change from when they were supposed to be looking at the Earth to, the little transition there.
It's
There
really
was
hard for me to
no.
understand what you're saying without watching the full video. I've only gone to where you've told me to go, so it's really
Yeah.
hard to, you know
Well,
what I mean? So
yeah. You said you saw it before, so
yeah, I mean I can
I
see
don't
that
know.
the Earth appears to be blue through the window, and then you're saying that there's a slightly blue light coming through the window, and that it's impossible for the Earth to reflect that much light.
I didn't.
And
No, that's not what I said at all. I said that it is the Earth causing the light to come in,
oh, you're just
and
saying that they're very low to the ground.
the size of the Earth from where they had just shown changes dramatically. It fills up the entire window, as
No,
where before, yeah, it fills up the entire window.
in that screenshot that you sent me, is that what you're saying?
In the video, I sent some screenshots. I think three of them
Yep.
of from the time that it shows the blue Earth in the window. You can't make out the shape of it
No, of
because
course you can't,
it
because
takes
it's
it
just
takes up
it's a
it takes
poorly
up the whole
adjusted
window. Well,
camera.
I mean, you could say that, but they didn't change the settings within those couple of seconds of transition.
Oh my
I
god.
mean, I think that they thought the camera was off. That whole
What? Okay,
entire that whole entire footage never even got shown. They were just practicing. They were practicing. They
practicing.
were
Okay.
practicing. Yeah.
All right. Yep.
It's
So
like a movie. You take a bunch of takes and you use the footage that looks the best,
you're
right?
right. So you're telling me that the organization that perpetuates this massive lie and organizes everything and has all this money, they just gave this to some guy to make a documentary, knowing full well what it was.
I didn't say that
There's a disconnect there.
I never said that they knew what it was. Why are you putting words into my mouth? I never said that they
How
knew
would
that they were
how would
sending
how would NASA not know that they had
because
their?
they if you listen to the guy, what's his name? He was an astronaut too. But he's on film saying that we don't have any of the telemetry data, and even if we did have the telemetry data, we don't have the machines to play it back.
Exactly.
And
Have you seen?
so you just answered your own question. You just, I mean, you say
No,
exactly, but yeah, you're saying that I said you said that I said that they knew that they were giving it to him. Well, how would they know that they're giving it to him if they didn't have anything to play it back?
because it's no. You've completely conflated what was said. That's a film. We have been able
Yeah,
to play film since it was invented. What they were talking
I
about,
agree.
telemetry data, is a completely different thing. It's completely different. The computers that we used, if you want to call them that, were archaic. It, I think you need to actually research more into the actual Apollo missions and move away from this. I can only call it propaganda. I don't know what else you'd call that.
Well, they lost like over a ton of footage. I mean, a ton of reels of film,
Okay,
and so I mean,
so that means they faked it.
no, that's not a solid evidence that they faked it, but definitely it definitely looks suspicious, I would
It looks
say.
like if they did do that, and I don't think they lost a ton of footage, but if they did do that, it would just prove that they're incompetent and they wouldn't be able to perpetuate this massive lie. Like,
Well, they are, in my opinion, they are incompetent. I mean, I've seen, that's the problem is I've seen so much footage where it's obvious that that people are on wires, on harnesses.
mm,
Um,
I've seen the footage as well.
there's the just green screen, and then they teleport stuffed animals, on screen, and
Mm.
you know,
Um,
there's a lot of different things that
well, what I'm going to try to do, because I think it will clear a lot of things up. I actually know someone who is a that works in a field of video editing, video forensics, that kind of thing. I think maybe if all three of us could get on, and we could talk about it, I think that might clear it up a little bit better because he's going to have a lot more knowledge that I obviously don't have.
sure.
So
Well, and there was people that analyzed that footage too. I mean,
yeah, yeah,
so I mean,
and lots of people have analysed it over a long period of time, and it has stood the test of time. So I,
I mean, I think that there's, because, I mean, I think that there's more proof that the moon landings didn't happen than there is of even flat Earth. I mean,
okay,
there's so much stuff that I can't even, you know, we didn't even go to. I just went to this one little snippet, uh, but a lot of the pictures don't add up. Me personally,
so
I've analyzed thousands of Apollo pictures and found all kinds of different problems with it.
okay.
Like
That can only be explained by them faking it.
that can only be explained by them faking it. Yeah, pretty
Yes,
much.
100%.
Yeah.
Pretty much is not 100%. Um,
Well, they say they didn't take any stage lights, but there's photos that are obviously stage lights that they say are lens flares, but they match up identically to the types of light bulbs, the shape of the light bulb. You can see the filament inside, and I mean, I mean, I'm not basing my my whole entire understanding and my whole entire belief system on
okay.
just one little bit of footage.
Okay. No, no, I didn't think you would either. I know you're smarter than that, but here's the thing. If you believe that the moon's close, I don't see, if you believe that the sun and the moon are close, I don't see how you can't believe that they went to the moon. So within your own narrative, that kind of works, but yet you're denying it so vehemently.
I didn't say they went to the moon. I'm
No, that's what I'm saying. Like,
okay.
okay,
So
so
yeah, they didn't go to the moon, and I don't think any rockets can go higher than about 73 miles.
73 miles. Okay. All right.
Yeah.
So where is the
Where's the
moon in
moon?
your model? Yeah, roughly. Like you don't have to give me a, but is it within that 72 miles?
No.
It's outside of the dome.
I don't think that anything is flying above the moon, or you know,
Yeah, but
or the
is the
sun for
moon
that matter.
beyond the dome, or is the moon within the dome? Is my question.
It's within it, I
It's
would
within it.
say.
So yeah, that's why I'm saying I don't see why they can't go to the moon in your model.
Well, because they can't get up high enough to go to it.
They can't fly
Because
72 miles.
I didn't say the moon was 72 miles.
It's within 72 miles, which is how high you said the dome was, roughly, or 70, 80
No,
miles. Or
no, no, that's not what I said. I said I don't know how high the dome
I
is,
don't know, but you
okay? And
estimated.
I think the dome is probably multiple different layers. You know, you know, there's you know talk about 7 different layers, okay? And I don't have any reference. You know, it's just even from ancient times, they said that there was 7. You know, the Greeks said that there was 7, 7. I don't think they called it heavens, but 7. Shoot. Um, there's been a lot of people throughout the ages that have claimed that there was 7 different layers or levels of the sky above us.
Right.
And I don't know if that's true, but I think there is different layers. I don't think it's just one, you know, shell that all the stars sit in at the same distance necessarily, or I think it's layers. It's complicated. I don't know. Uh, like I said, I've never been there,
Okay,
so
no, that's fine. You're saying all you have to say is I don't know. That's it. You don't have to. You don't have to keep going. So it's fine. I'm not expecting you to answer every single question, but I do expect you to say you don't know when you don't know, and don't just assert something.
yeah, I don't really like speculating on distances to things that no one's ever been to.
Okay, cool.
Like
So do you know how an EME bounce works?
there's some kind of radar that bounces
Yeah, it's
off
a yes, essentially,
some
yep. Bounces off
distances.
something, and
Okay.
then you can measure it and find out how far away things are.
Okay. Now
Yeah,
that
no,
isn't that a
I'm not finished.
doesn't that assume? Okay, sorry.
Sorry, I'm not finished. Do you know the speed at which a electromagnetic radio wave would propagate out?
Well, it's supposed to be at the speed of light, probably in a vacuum through the
Yeah, I
atmosphere. I
mean,
think it's a
yeah.
little bit
So
different, right?
yeah, it's a little bit different, but it's negligible. It's within tolerances, so it doesn't matter. So if someone was to do an EME bounce and was to measure that, what, and it came up to be the same as what the popular science has postulated, would you accept it?
Well, to be honest, I haven't really looked into. You said IME. What
EME,
was that you said? EMA.
EME.
EME. I haven't really looked into EME. The technology for it. I'll be honest. But I'm gonna say that I think it is based upon the speed of light,
Yes.
and the speed of light varies depending on mediums. We don't, I guess, space is supposed to be a vacuum, so it's supposed to travel at, what is it, 186,000 miles per hour or whatever, right?
Mhm.
So, but the speed of light has been shown to vary, from time to time.
Okay.
And
Well, that's by how much? What's your?
I think it was like 20 seconds. I think it changed or let me think. Hold on.
Okay, but what I'm asking you is within a tolerance, if you shot a beam and it was reflected and you measured the time difference between when it left and when it returned, could you not then extrapolate the distance to the said object?
Well, I think that, like I said, the speed of light varies, and I think the speed of light has been tested on the Earth. In even in a vacuum, I think that there's, you know, I think it varies by distance too. Like if you're measuring a small amount, I don't
Does
know
that?
if it necessarily stays the same at a long distance.
Okay, but that's not what I'm asking. I'm asking whether that's an acceptable measurement or not. All you have to say is yes or no, because I just need to know whether you're going to accept it as evidence or you're not.
I guess I would have to look into it. I would have to look into it more, to be honest. I mean, I know that they have bounced signals off of the ionosphere. I know that so I don't really know. I guess I just don't know the technology good enough to make a
Okay,
determination.
okay, it's fine just to say no. Like it's just it's yeah.
Well, because I'm not saying no, because I'm open. I'm open minded to learn how the technology works, and to you know I'm not gonna totally just say, oh no, I'm not gonna accept any proof. That's ridiculous.
Right, because it has been done. It's been done by lots of people, amateurs and professionals alike. And
Well, but the thing is, you don't have any. I mean, the only reference that you would have is right here on Earth. You know, pointing, shooting something into the sky. It just where are the numbers based on? It's based on the speed of light, right? So
yes, so what?
if the speed of
Okay,
light,
but you've
if
said
the
this 10
speed of
times now. So what's
well,
okay? So the tolerance. If it was varying by 25%, I'd say yeah, man, that's no good. We can't use that. But it's not. It's not varying by that much. It's. I'm not sure about the numbers that you're referencing, but I think that you.
what's the control? Like, you shoot it into the sky and you say, "Oh, the moon is 240,000 miles away," but where do you get the
Okay.
scale from?
Okay. So if we have a constant speed of light, yes.
But the speed of light has been shown to change, though.
Oh my god. By how much? Actually, I don't even want to get into this right now. Again, I'm not going to do this again. Let's just say that it's constant for argument's sake, because it's starting to annoy me, right? So we're just going to round it up. Actually, no, we're not. I don't want any more confusion. If I shot, let's just say that I have something that travels at exactly 100 kilometers per hour, and I shoot it at something far away, and I want to know how far it is, and it comes back to me in 2 hours. How far away would you say that that object is?
An object. Say that again.
I shoot a beam let's just say a beam that travels at exactly 100 kilometers per hour, or miles per hour if you want to.
Oh, okay.
And I shoot it at an object, and the time between me shooting that and it returning to my receptor is 2 hours. How far away would you say that object is?
200 miles.
No, it's half the distance.
If it goes there and comes back,
If it takes two, if it's traveling at 100 miles per hour, sounds funny to say that. I don't know how you guys say it all the time. So it travels 100 miles every hour, and I shoot it at an object. If it comes back in 2 hours, then it's traveled 200 miles. That means that the object is halfway between that distance. So the object is 100 miles away.
Oh, right.
Okay.
Yeah,
cool.
I guess I was thought you meant the round trip.
No, that's fine, man. That's all good. No biggie. So that's fine. You agree that that's a good way to measure things, right?
I guess if you don't take, atmosphere and,
Yeah, but because
wind currents and directions, and if you're talking in a vacuum, then sure.
you wouldn't need to take all of that into account.
Well,
it's negligible. It's within a tolerance, and that's why I keep bringing up tolerances.
I see, and I don't see that because I can look up in the sky and I can see clouds blowing 3 different directions at once, and different layers are blowing different directions, and I mean, so in a distance of 100 miles, it's gonna. I don't understand how it would be negligible for, like, shooting a projectile or.
Do you want to know what the difference is in between traveling through light traveling through a vacuum and light traveling through the atmosphere?
Well, I guess you'd have to have a standard amount of what you call atmosphere, right?
Right. Well, I don't think you're getting
Don't
the
you
point.
think?
Yeah, I mean,
Well, the atmosphere obviously causes drag on things. It causes, obviously, if wind's blowing and there's drag on objects, it's gonna move them. It's gonna displace them, right?
Is light going to be affected by wind?
No, not wind, or not light.
Okay. So what is going to affect a single photon traveling at 300,000 meters per second? 300,000 meters per second.
I don't know. Maybe electromagnetic field. Maybe there's all. I mean, who knows what?
That's what I've been trying to say, is that we can shoot we can shoot a beam at the moon, and we can count the time between when we fire it to when we receive it back. Okay?
I understand.
And halfway between, yes. So you know the speed at which it's traveling within 1% or 2%. That's how close you're going to get. It's not going to be a difference of either 120,000 kilometers or 72 miles. That's not the range that we're working in. We're working in a very. Do you understand what I'm trying to say now?
But I never said that the moon was 72 miles away.
Okay, I know that. I'm just giving an example. You're saying that it's not. You're saying that it's not 350,000 kilometers away.
I don't think it's that far away. But
Yeah, but that's what I'm saying. Whether the speed of light through the atmosphere changes by 5% even, it's still going to be a very long way. It's still going to measure a very long way. So I think that for the sake of the argument, it's perfectly fine the way that I'm describing it. And I think that you're just
but the thing is I don't think the space is a vacuum.
that's fine what you think, but
Well, it's going to travel differently and through a different medium.
not that
I
much.
still believe that
It's not that much.
space is
It would have to slow down a lot for it to affect your
the
measurements.
the problem is I don't think anyone's been to space. Okay,
I know
so
that's
so any measurements have been taken on the Earth. Okay,
correct.
so your control is automatically going to be it's already wrong.
No, no.
You don't have anything testing the speed of light in space, though. That's what I'm
What is
saying.
space?
You're
What is
doing
space?
uh, the absence of
It's
particles,
yeah,
supposedly.
it's a near
But
vacuum. It's not a
it,
perfect vacuum. It's a near vacuum. So
it,
we can create something it's a pretty good vacuum, and we can shoot
it,
a coherent beam of
have you
light through
ever
it. We can measure.
have you ever heard of what's that guy's name? Shoot. He's a Nobel Prize winner in physics, and he
Uh,
talks about the ether,
oh,
and
yep.
it's not the luminiferous ether, and even Lawrence Krauss. You probably heard of Lawrence Krauss, huh?
Yes, I have.
Lawrence Krauss even admits that yeah, the ether is real, but it's not the ether that they thought it was back, back in Michelson Morley and
Well, where's
you
the
know,
context for that?
huh? Well,
You
because
need
I believe that there is a substance, even if we can't necessarily measure it or test it. Even you believe that. I mean, I'm assuming you believe in dark matter. If you believe in the standard model, right? Dark matter, dark energy, right?
I wouldn't use the word believe, but yes.
Well,
I'm just saying.
what's a better word to use?
I believe that the word to use would be that the evidence would point to the fact that
Well, not to me, it doesn't. I mean,
well, that's fine.
to
But
me, it doesn't.
what you're saying is it's not black matter. It's just ether.
I didn't say that at all. I'm just saying that you know our understanding of what is our understanding is limited. You know, like they say we don't know about 96% of everything that's supposed to be in space. You know,
You just
so
said you just said that space was the absence of matter, like not even 2 minutes ago.
officially, that's what it's supposed to be. I said officially, but there's other theories that I am, seeing that are replacing, you know, slowly it's becoming an electric universe. But there's a lot of there's a lot of debate. There's a lot of it's all different theories. It's all different theories that people have came up with to try to
Like
explain
the theory
everything.
of like Einstein's theory of general relativity,
Yeah, like
which
I,
works really, really, really well at describing reality.
well, but you realize it was conjured. It was a conjured.
Conjured. It's
Yeah,
an
it was
interesting
conjured.
word.
It's a transformation. They basically Einstein's theory of general relativity relied on the existence of ether. Okay, it relied on it. You would you agree with that?
I'm not sure that I
That
would
the
fully agree with that.
well, it relied on the existence of ether. Ether was part of the part of the theory. But my point is he developed special relativity to explain so many null results. They call it null. It was actually like 1/5 or 1/6 the speed that they predicted it was going to be. They said it was going to be 30 kilometers an hour for the rotation of the Earth through the ether. Okay. And they actually only ended up with 1/6 or 1/5 of what they predicted, and they called it null results, even though it was still 1/5 or 1/6. And they created the Lorentz transform because when matter in the theory of special relativity, when matter is moving faster, it's more it gains mass, right? And the length contraction, right?
Okay.
And so to explain away the 1/6 speed, they came up with length contraction ad hoc. There was never, hold on, before you interrupt me, because I could hear you wanting to, there was never any postulation of length contraction prior to that. Okay. Or, it was basically an ad hoc thing. They had no proof of it. There was no, there was no evidence to point to that,
Mm-hmm.
but they, they found a way mathematically to transform it into a different uh, reference point, a different I'm losing my words now, but
Did you just say that
basically
there wasn't something, and then someone predicted it, and then
no, I said they never theorized that there was length contraction. Okay, they never that was never the length contraction was basically they had to find a solution to deal with why there was only 1/6 speed and not the 30 or whatever they were expecting. Okay, length contraction was ad hoc to explain why the Earth wasn't moving through space.
why are you saying why are you saying ad hoc?
Because it was never even a theory. It was never even postulated to as something that occurs until they were
Till it was
you
postulated.
know no until until they found that there was no in the Michelson Morley, Dayton Miller, Picard. There was all kinds of people doing interferometer experiments all over the world. Dayton Miller did it over 100,000 himself personally, and they never were able to detect what they were supposed to detect.
Someone just said in the live chat that cold weather causes length contraction.
Cold, yeah.
Yeah. uh, look, man, I gotta get going. All right.
Well,
It's been fun talking to you, but I got to start early in the morning.
there you go.
So
All right, it's been good.
yeah, man. So look,
Check out, a lot of these topics that we've been talking about, I've made some videos on my channel, and anybody who's in the chat or whatever, you guys can check it out too.
yep.
I mean,
So what's your channel name again? Just for everyone.
it's called Fight the Deception.
Fight the Deception on YouTube. Beautiful.
Especially that angular, it's called Angular Resolution. It's a playlist
Yep.
on
I'll
that one.
definitely
So
check that one out. And like I said, 2 weekends from now, we'll if the timing aligns, we will reconvene and continue the
sure.
discussion. I should have some
What
nice.
was your channel, by the way?
I'll send you the link. It's just Incompetent Inquisitor.
Okay.
Yeah, so I started it more to be about learning how to use telescopes properly, but it's kind of boring and no one wants to watch it. So if anyone does want to watch it, leave a comment and I'll start making videos. But yeah, we'll get back. I'll try and get my
Oops. I don't know
friend
what I
in.
just did.
I'll try and get my friend in that can answer a few of your questions about video manipulation and stuff like that.
All right. Sounds good.
Cool, man. Well, thanks everyone for watching.
I'm sure we'll see each other in the chat there.
Yeah, definitely. Maybe next time some of the other guys can come and join in. We'll have a moderated discussion.
I meant the messenger chat.
Yeah. Yeah, so did I.
Oh, okay. All right. I stayed up all night talking to you, so it's like
Yeah, I appreciate it, man.
6 o'clock here.
And there was one question from the live chat that I didn't get to. I'd like to
Sure.
read a couple to you. You don't have to answer unless it's a question. One guy said, I've lost the question because it was so long ago. Some flat earther came in and asked how are planes speeding up sideways on as they fly south to the equator from the north. No one has ever answered this.
Yeah,
That doesn't even make any
true.
sense to me. What's
Well,
true?
I think what that person's saying is in real life, an airplane takes off from point A, it flies to point B, it doesn't lead its target, and at the equator, it's supposed to be rotating like 1,100 miles an hour.
Yep.
At the North Pole or the South Pole on a globe, um, if you're traveling from the equator to the North Pole,
Mm-hmm.
and your momentum stays, your because they say that if you take off from the Earth, you already have the speed that the Earth was rotating, right?
Yes.
So if you took off from someplace that was speeding,
Mm-hmm.
speeding at 1,000 miles an hour or 1,100 miles an hour from the equator, and you flew to Alaska or something like that. Excuse me. If you flew to Alaska, you would, you should retain the speed that you were going, right? The 500 or the 1,000 miles an hour. You should retain that speed. So if you were to land on a north south or on a north south facing runway, while you or the Earth have the extra momentum or the you know what I'm saying, right?
I understand your point. I'm waiting for the contradiction.
Well,
I'm waiting for you to say
basically,
something that disagrees with the
the
globe.
Earth, if the Earth was rotating underneath of objects,
Uh,
the time would be different for flights. There'd be all kinds of differences if you were
okay.
flying
Didn't we just
opposite direction.
discuss relativity?
Yeah, but we discussed relativity, but these are reasons why relativity, you know,
So you're saying that the atmosphere
exists.
would not move with a globe? Is that what you're trying to say?
No, but the thing is, I can see the atmosphere blowing by.
No, you can't.
You know,
You can't
well,
see the
I
atmosphere. You can see some effects of some wind, but you can't see
I
the
can
atmosphere.
see the I can see the clouds blowing by.
Yeah,
You know,
that's not the
that's
atmosphere.
part of the app. Well, it's
It's
part of it, right?
well, just as much as you are as a part of the atmosphere.
Uh,
Well, it's true. I mean, anyway, this isn't going to. Yeah, that's fine. Maybe I'll answer that idiot's question another time.
Well, maybe I didn't hear that correctly or something, but
No, that's fine. It doesn't matter. There is one question.
I think the Coriolis, you know, what they say should happen just doesn't happen. It just doesn't exist.
Okay, that's fine.
I mean, there's like Neil deGrasse Tyson says like football
Oh,
can't
I know
be
what you said. Yeah,
infected,
I hear it all the time.
and then on the other hand, rockets and missiles and artillery, they don't take curvature or rotation into account.
Okay. Really wish people would stop quoting Neil deGrasse Tyson, because even though he is a
I
even
bet you would.
okay, listen, even though he is a science popularizer and he's out there communicating science to people,
Well,
he is
he's an
not.
astrophysicist,
Let me finish. He's not
right?
he is not the leading edge. He is not at the forefront of science. Okay, and he is not a representative for the entire scientific community. So he could go out there and say that Green Gremlin stole his wallet. That doesn't mean that anyone has to believe him. Okay, and that doesn't mean that what he's saying is completely and 100% factually true. And it doesn't mean that that's what he's implying either. So when people say things like that, you're asserting that I believe everything that he says.
No, but
But every time I
he
bring up the
is.
Coriolis effect, that is the first thing that gets brought up. Literally, and
Well,
whenever you bring up the shape of the
it's
Earth, they
it's a
go, "Well, Neil deGrasse Tyson said it was a
it's a
pear."
contradiction. It's a contradiction. I mean,
How many
it's
contradictions have I pointed out in your observations tonight? If you're going to dismiss things just on contradictions alone, I think that we're going to have a problem here. Not on my side. But here's a question.
well, in my opinion, you haven't examined the footage uh,
Well,
as closely as I have. I
I
mean,
did it frame by frame, but that's fine.
I've watched it. I've watched it probably 20, 50, a
That's
bunch of times. I mean,
that's fine. Here's a question. This Aegis, I think I'm pronouncing it properly, is asked. This will be the last one, and then I'm out of here. So it says, on a flat plane with an unobstructed vertical object, at what angle should the vertical object be most visible?
uh, what angle should it be? 90 degrees, right?
Yeah, perpendicular.
Is it the object, if there was a pole, right?
He just said the correct answer is perpendicular at the center point of height.
Be
Yeah, and someone said so. Tropical
not,
storms in the two hemispheres don't rotate in opposite directions. There is a
no,
tropical
they
storm.
do.
Yeah,
They
there is a
do.
tropical storm about to make landfall now. I think on near
But
Texas.
my argument for that is if the sun and the moon are both moving in a circular path around over top, or in
Yes,
a
I've heard this before, like a hand through a
revolution,
bathtub.
then the sun and the moon would make a kind of like a wake.
Yeah. I've heard it before. I think we can
Like
examine it next time that we're on. So
yeah, okay, I can
if you want to get some videos up, like get some links and stuff sorted out for that, we can go over it live. It'd be
all right, I can make a video about that.
cool, man.
I mean, it's just the way fluid mechanics work.
Yeah, Aegis just replied. He said the point was to show that you wouldn't see more stuff from further up. You'd actually get a contraction of the vertical object. That's true, which means it would disappear at a closer horizontal separation. So that's a good point. But yeah, half an hour over. So
Yeah, like I said, go to that playlist and check out the
yeah,
playlist
we'll do, man.
called Angular Resolution. It's got a
Yep.
bunch of
I'll see if that answers this
information in
question.
there. Yeah.
No worries, man. Well, that's me for the night. So I'm gonna get out
All
of here.
right. Good night.
Cool, man.
Good night, and I'll send you some links, or I'll post some links about vaccines because we never got into that. I'll
No,
post some
that
links.
might need its own episode, I think.
Yeah. Okay.
Cool.
I'll share some links with you just so you can
Yep.
just for you personal, for your personal knowledge or whatever.
No problem. No problem.
Right on.
All right,
Have
man.
a good one.
You too.
Later.